We don't fear the loud things we can see. We fear the quiet thing that slips past our eyes, chooses the angle of the sun, and arrives while we argue about headlines. The monster headed for Earth next week is not the celebrity comet plastered across your feed. It isn't 3I divided by Atlas. It's the faint one, real, close enough to matter, and late enough to expose how fragile our vigilance really is. Here is the truthful claim, made precisely on the 14th of October 2025. A newly tracked comet, informally called R2, will pass Earth at a cosmically close but safe distance next week. Current solutions place the miss in the tens of millions of kilometers, which sounds comfortable, and it is. But that's not the story. The story is why we noticed it late, why the public conversation keeps orbiting a flashier object like 3I divided by Atlas, and why the quiet ones are the ones that actually test our readiness. If your information diet is headlines, you'd be forgiven for thinking danger equals novelty. Interstellar is the magic word that buys attention. Anything with a mysterious origin draws oxygen. Anything homegrown draws a footnote. But the solar system does not grade on novelty. It grades on dynamics and time. Objects that hide in solar glare, bloom after perihelion, or fragment without warning are the ones that bend our risk models out of shape. R2 checks several of those boxes. It slid through the bright geometry near the Sun, then sharpened in brightness when geometry and activity aligned. By the time the paperwork caught up provisional designation, orbit fits, updated ephemerides, the narrative machine had already clicked toward louder bait. So, what precisely is happening? In late September, observers flagged a candidate. Follow-ups refined the orbit. The Minor Planet Center performed its job. JPL incorporated fresh measurements into its solutions. None of that generated heat, because the pipeline is designed to protect accuracy, not to feed panic. Silence in that context is procedural, not conspiratorial. But silence has optics. We mistake the absence of breathless coverage for the absence of significance, and in that blind spot we grow myths. They're hiding something. Or, if it mattered, I would have heard. Meanwhile, the sky, indifferent to our attention economy, keeps moving. Uncertainty is not denial. It's a label on the map that says, area not fully surveyed. Between now and closest approach, that label shrinks as more photons hit more detectors. If outgassing injects a small non-gravitational term, the path shifts by a hair. If the nucleus stays quiet, it doesn't. Either way, the adult posture is to watch the data in good faith. That isn't boring. That's how civilization acts under clocks and constraints. A pass that is safe at the macro scale can still be operationally meaningful at the micro scale. Micrometeoroid background, false positives in pipelines, stress tests for staffing and documentation. You don't need an impact to learn the right lessons. You need the discipline to treat a non-event as data. Why bring 3I divided by Atlas into this at all? Because it is a mirror for our distortion. 3I divided by Atlas is dramatic, yes. It's also, for the next 8 days, less relevant than a low-profile comet cutting across our models from the wrong direction at the wrong time. Novelty captures attention. Proximity test systems. You cannot read satellites, schedule spectroscopy, or calibrate meteor cameras with a vibe. You do it with ephemerides, signal to noise, cadence, and checklists. That is the real story. Not doom, but readiness. Not a scream, but a system working under pressure. So let's set aside the thumbnails for a minute and sit with the math. A miss is still a test. A quiet pass can still raise the micrometeoroid background, still expose brittle thresholds in detection pipelines, still surface the institutional entropy that creeps in when documentation gets dusty and a generation of expertise retires. The sensible claim is not, we're in danger. It is we're being measured by our own ability to see, decide, and communicate when time compresses. The monster next week isn't an impact. It's indifference. It's our habit of ignoring the near because the far looks cooler. If we can resist that habit, the next 8 days become a clinic in adult spacefaring behavior. Calm, transparent, and honest about what we know and don't. Let's name the stakes without melodrama. Late detections compress time. Compressed time forces triage. When triage meets public spectacle, the signal collapses. Part of that collapse is on us, the audience addicted to novelty. Part of it is on institutions that publish through technical portals that the public can't parse. And part of it is the sky itself, which does not care about our deadlines. The result is a familiar pattern. A real object quietly enters the theatre. The public camera pans to a different stage. Experts keep working. Rumors keep breeding. Here is what competence looks like for the next week. Observatories maintain high-cadence photometry to flag sudden brightening. Spectroscopy hunts for gas signatures, CN, C2, OH, that betray vent locations and instability. Radar windows are checked, even if range and cross-section make them marginal, because a null result is still a constraint. Wide-field meteor arrays tune for flux changes, in case a diffuse dust trail brushes Earth's environment and nudges the micrometeoroid background. Satellite operators review protective modes, panel orientation, safe configurations, graceful degradation strategies, because planning beats improvisation. Meanwhile, the orbit keeps tightening with each usable measurement, uncertainty shrinks, and the space between panic and complacency is filled with work. Does that mean R2 is dangerous? No. The parent body is on track to miss us by a comfortable cosmic margin. But comfort is not the correct metric. The correct metric is learning per hour of observing time. R2 is a live-fire drill for blind spot management, solar ward coverage, threshold tuning as the sky grows crowded with satellite streaks, staffing continuity, so that institutional memory doesn't age out of the building. This is where both extremes, the speculative doomers and the institutional cheerleaders, miss the mark. The point is not to predict a disaster or to promise invulnerability. The point is to practice competence under constraint, again and again, until the muscle memory holds even when the next object is faster, dimmer, or poorly lit. Media skepticism belongs here too, not as cynicism but as hygiene. If a claim leans on adjectives and refuses numbers, park it. If a thread cherry-picks graphs without telling you the window function, park it. If an explainer treats interstellar as equivalent to important right now, park it twice. Reward the unglamorous updates, ephemeris tables, uncertainty cones, instrument notes, calibration caveats. That is how you participate in safety culture. Attention is a resource. Spend it on the work. We will be transparent about the cadence. If outgassing pushes a measurable non-gravitational parameter, we'll say so and show the delta. If meteor networks see a transient uptick synchronous with the predicted node, we'll say so and show the counts. If nothing happens, we'll also say so because nothing happened is itself information, a quiet proof that preparation mattered and thresholds held. That isn't hedging. That is what communication looks like when consequences are real and clocks are running. So yes, we will mention 3IATLAS briefly to reframe attention, not to stoke it. The narrative here is different from the feed. We are not selling fear or miracle saviors. We are selling the sober excitement of watching a complex system do the right thing under real constraints. That is the title claim right now. On the 14th of October 2025, the monster headed for Earth next week is not 3IATLAS. It is our appetite for spectacle when we need discipline, our reflex to confuse novelty with relevance, our temptation to abandon attention the moment a story turns technical. If we can resist that reflex for 8 days, if we can reward the work instead of the noise, we will have done more for planetary safety than any headline could. Stay with the data, watch the cadence, learn the difference between silence that hides and silence that protects accuracy. In a week, when R2 slides past and the world shrugs, you'll know something the thumbnails never taught you. A non-event, studied well, is how we keep the loud events rare, and that is how adults live in a moving sky. A single ultraviolet ghost is all it takes to change the story. One faint hydrogen glow in a sea of solar noise, barely above threshold, slipping through the sun's glare. That's where this begins, not with a viral image, but with an instrument built for discipline. Swan, the solar wind anisotropies camera aboard Soho, doesn't chase comets for drama. It maps hydrogen in the heliosphere, day after day, the same way a cardiologist listens for rhythm instead of applause. Here is why that matters today, the 14th of October 2025. When a volatile-rich comet swings around the sun, water molecules split under sunlight and release hydrogen that shines at Lyman alpha. Swan sees that signature across the whole sky. It is low resolution, yes, but it notices what our eyes, news feeds, and even many telescopes can miss. A quiet increase, a patch that moves with celestial discipline. That patch became a candidate became a report, and a report became a provisional designation once the pattern held across nights and the motion solved cleanly. Admiration belongs to the method. First, the detection is statistical. Engineers build a background model of the diffuse hydrogen glow, subtract it, and look for residuals that persist across frames. They reject cosmic ray hits, streaks from satellites, solar stray light, and processing artifacts through rules that were paid for in mistakes. Then they test for motion with time-separated images. Does the residual shift exactly as a solar system object should, given parallax and expected rates near elongation limits? If it does, you've earned a candidate. If it doesn't, you've earned humility. Next comes triangulation. Ground-based observers open the morning or evening window when the geometry finally lets the comet clear the Sunday. They run short exposures to freeze trailing, or they deliberately track on the predicted non-sidereal rate and let the stars streak. Either way, the goal is the same: high-quality astrometry, precise centroids for a moving blur, and photometry clean enough to estimate activity. Every coordinate arrives with uncertainty bars. Every uncertainty bar feeds a solver. At the minor planet center, the math turns those rows into a first-cut orbit. Simple Gauss or Laplace methods seed the elements. Weights are assigned, outliers are trimmed, the fit iterates until the residuals tighten or a better set arrives. JPL's Horizons then refines the solution as more stations report, folding in a realistic dynamical model and, if warranted, small non-gravitational terms from outgassing the A1. A 2 sunward heat cycle, non-gravitational term, are 3 accelerations that nudge a nucleus like a whisper. Each iteration narrows the cone of uncertainty. Each night either calms the model or alarms it. All of this sounds serene. It isn't. The blind spot is baked into geometry. Sunward approaches live where most cameras refuse to look. Weather eats nights. Schedules collide. Pipelines drown in satellite streaks. And the threshold you set to avoid false positives is the same threshold that can bury a real signal for one more day. We admire the method precisely because it works under that pressure. Swan is not a comet paparazzi. It's a metronome for hydrogen. When its beat stutters, the community leans in not because doom is certain, but because measurement got interesting. This is why R2 matters now, while 3I divided by Atlas monopolizes novelty elsewhere. R2 teaches the adult lesson. Geometry governs risk perception. Cadence governs certainty. A faint hydrogen patch, properly treated, can move a story from rumor to orbit in 48 hours. That is the quiet miracle of procedure. The same tools that protect us from panic also protect us from complacency. Quiet rigor beats spectacle when the clock and geometry conspire. Start with geometry and cadence. Swan flags a hydrogen excess. A minimal orbit is fit. The window opens as elongation increases. Ground stations hand off along longitude. One team images at civil twilight when the comet barely clears the horizon. Another takes over 90 minutes later as the sky darkens and the rate of motion changes. Observers coordinate non-sidereal tracking so the nucleus stays still on the detector, and the star field smears a simple reversal that turns a faint wanderer into a measurable point. Every step has a failure mode. Thin clouds, corrupt flats, wind degrades seeing, guiding drifts, the centroid shifts, and the error ellipse stretches. Satellite trains rake the frame. A cosmic ray cleaner mistakes a nucleus for debris. Pipelines carry assumptions about sky brightness, gradients, and how many pixels define a point source at that FWHM. The lesson is unsentimental. The sky changes. Thresholds must change with it. Now, the institutional rhythm. Astrometry lands at the MPC in standardized formats. Submitters identify observatory codes. Timestamps are UTC. Positions include internal uncertainties. The clearinghouse bins the data, resolves conflicts, and posts circulars. The solution improves as more chords cross the orbit. JPL's Horizons publishes fresh elements. Propagate forward, and you get ephemerides where to look, how fast the comet moves, how bright it might be. None of this is glamorous, and all of it is necessary. Admiration deepens when you see how many people do small things right. Someone keeps the time server honest, so a millisecond doesn't become an arc second. Someone babysits a cooling leak so the detector doesn't grow hot pixels overnight. Someone rewrites a photometry script because the field now contains a variable star that mimics a nucleus in one filter, but not another. Craft means knowing when the pipeline lies and catching the lie before it damages the orbit solution. The anxiety never leaves, and it shouldn't. Sunward comets arrive in the donut hole most surveys avoid. Evening and dawn windows are short. Air mass is punishing. The target is low, red, and swimming in gradients. You celebrate a single clean frame, the way mountaineers celebrate a weather break, with gratitude and speed. If outgassing adds a small non-gravitational acceleration, the fit must absorb it. If not, predictions wander. That is why you watch cadence. Not just single snapshots. Sequences tell you what a moment hides. Practical value for viewers. Read updates like an adult. Treat closest approach numbers as moving targets that harden over time. Watch uncertainty cones shrink day by day. Favor sources that show residuals and cadence. If a post won't publish an ephemeris table, it probably isn't serious. If a headline sells doom without a geometry plot, it's performing, not informing. And if a segment name drops 3i divided by Atlas to spice a story about R2, ask whether proximity, geometry, and timing actually support the comparison. What improves the system next time? More solar ward coverage, small coronagraphs or UV images with stable vantage near L1 or Earth-trailing orbits. Better twilight surveys with non-sidereal modes baked into the nightly plan. Public dashboards that translate MPC and Horizons outputs into plain language visuals so the speculation vacuum doesn't form. And most prosaic staffing continuity, documentation, mentorship, and drills. So, muscle memory persists when people rotate out. This is the connective tissue to our next chapter. Now that the detection chain is running and the object is tracked, we leave mechanics of seeing and enter the behavior of the thing itself, its chemistry, tail, jets, and the way fragments turn one body into a moving field of probabilities. Admire the method, keep a healthy fear, carry both forward as we step from discovery to dynamics together. It didn't happen with a roar. It happened with a quiet surge, the kind you only notice when you've been staring for hours and the horizon is just beginning to bruise with dawn. In one frame, the coma looks tame. 3 frames later, the curve steepens, the halo blooms, and the tail grows a ragged tooth that wasn't there before. R2 didn't ask for attention. It simply became impossible to ignore. Here's the timeline that matters. Discovered in mid-September and past perihelion on September 12, R2 spent late September teaching us humility. The light curve jumped by a fraction of a magnitude that reads like noise until you remember that magnitude is logarithmic. Half a magnitude is not a shrug. It's a substantial increase in reflected and emitted light. Photographs taken at civil twilight showed a coma with a green cast, the classic signature of diatomic carbon, C2, fluorescing under ultraviolet sunlight. Around the same time, narrowband observers flagged OH emission, water vapor, broken by sunlight into fragments that reassemble into clues. Chemistry isn't decoration here. It's a codebook. C2 tells you about carbon-rich volatiles near the surface. OH points back to H2O, the workhorse volatile that drives jets, fans, and the slow violence of outgassing. The ore is in the details. Look closely, and the tail stops being a cartoon arrow and becomes a record of forces. Dust grains of different sizes carry different fates. Big, sticky grains resist solar radiation pressure and lag in a dense, slow cloud. Fine grains sail, tracing clean parabolas down sun. If you map those grains with lines of equal ejection time, synchrones, and equal radiation to gravity ratio, syndines, you get a star chart of the comet's recent behavior. R2's early October images showed just enough structure to make those overlays worth doing. A kink here, a streamer there, suggestive of localized vents turning on and off as the nucleus rotates. Even without a resolved disk, you can read the rotation in the tail's heartbeat. A repeatable brightening on one flank, a fade on the other, a cadence that argues for an active patch sweeping in and out of sunlight. Now fold in geometry. With the phase angle increasing, forward scattering can punch above its weight. Sunlight glances off dust and bounces straight into our detectors, making the coma appear brighter than composition alone would predict. That's why we don't anchor everything to a single night. You follow cadence a string of nights, same filters, same apertures, and you compute AFRO, dust production proxy, the pragmatic proxy for dust production that lets you compare apples to apples across telescopes and moments. On some nights, R2's AFRO rose enough to justify the word outburst. On others, it flattened, as if the nucleus exhaled, then rested. Caution is the shadow of wonder. Every outburst is a reminder that comets are not monoliths. They're rubble piles and porous ice, stitched by weak gravity and surface crust. A vent clears, a slab cracks, pressure builds, then a lobe gives way, and the comet redraws its own biography in minutes. That's when you watch for drift that isn't gravitational, the whisper accelerations. A 1 divided by A, 2 divided by A3. An active nucleus can impose on itself. You can't see the push. You see its consequences, residuals that won't quite settle if you pretend all forces are Newtonian and clean. Add a small non-gravitational term, and suddenly the solution breathes easier. Subtract it, and the ephemeris grows shaky at the edges. None of this is doom. It's the honest choreography of a body waking up under sunlight. R2 glows green because carbon reacts to a star 150 million kilometers away. It breathes water because its skin keeps finding weak spots. It grows a tail because the solar system itself is asymmetric, gravity on one side, radiation pressure on the other, and dust is the witness. The astonishment is not that any of this happens. It's that we can watch it in real time, tease physics out of pixels, and see the universe speak chemistry in a language we can learn. Awe deepens when you stop treating the tail as decoration and start treating it as a sensor. The tail says whether the nucleus is shedding large grains, heavy dust retention near the coma, or atomizing fines, long, smooth downsun streamers. The coma asymmetries, those bright wedges that look like someone pressed a thumb into the halo, betray jets. Collimated flows from vents that behave like garden hoses on a rotating platform. If you time those asymmetries across an observing run, you can back out a rotation period window and even guess at the latitude of active regions. That's the workshop magic of comet science. You don't need a spacecraft to do real diagnostics. You need cadence, filters, and patience. Instability never truly leaves the frame. Watch the isophotes' contours of equal brightness over a week, and you'll see them warp and relax, sometimes as the phase angle changes, sometimes as real physics intrudes. A brief, sharp brightening followed by a slow fade can mean a vent unclogged, then partially sealed by refreezing material. A longer, ragged surge can mean mass-shedding chunks liberated from the surface, too big to be blown far, lingering as ghostly condensations just below the detection comfort zone. When those chunks exist, they don't have to hit anything to matter. They tweak coma morphology, they shift light curves, and if confirmed, they would tighten the case for non-gravitational terms in the orbit solution. This is where geometry and chemistry clasp hands. Narrowband filters isolate C, 2, Cn, O, and sometimes OI, if the instrument permits. Broadband captures the dust continuum. Compare the two, and you disentangle gas-driven structure from dust-driven glare. Now lay synchrones divided by syndins on top, and the sketch becomes a map. Ejection times here, particle sizes there, a plausible story about when and how the nucleus last changed state. A comet is an argument written in light, and the tail is its margin notes. For viewers, here's how to read the next week like a practitioner. If you see a night-to-night increase in afro paired with a developing fan or jet wedge at a consistent position angle, suspect a stable vent pattern under solar heating. If you see an impulsive brightening with a short-lived spray that shrinks fast, suspect a burp, a pressure pop with minimal mass loss. If the residuals in updated ephemerides improve when non-gravitational terms are allowed, you're probably witnessing real outgassing thrust, not just measurement noise. And if meteor watch networks report a tiny, time-limited uptick, timed to when Earth skirts R2's projected dust plane, that's a laboratory in the sky, confirming what images whispered. None of this means catastrophe. It means honesty about the possibility. Comets are unstable by nature. Instability is the very reason they're worth our breath. You don't tame instability by denying it, and you don't monetize it by screaming. You characterize it chemistry first, morphology second, dynamics always, and you let the numbers set the tone. That is the difference between awe and fear. Awe is what you feel with the data. Fear is what you feel without it. Why mention 3I divided by Atlas here at all? Because it's the foil we need to highlight R2's subtler urgency. Interstellar stories caught clicks, but a native comet with active vents, evolving coma geometry, and a light curve that won't sit still, that's where science squeezes the most learning per hour right now. R2 is not louder than 3I divided by Atlas. It's closer to the levers that test our pipelines, our patience, and our ability to keep a civil conversation with the sky. So, as October 14 closes and the cadence rolls forward, hold two truths at once. First, be astonished. Sunlight, carbon, water, and dust are improvising a physics lesson across tens of millions of kilometers, and we get front row seats. Second, stay cautious. A body that outbursts can outburst again. A tail that sharpens can split. A nucleus that breathes can nudge its own path in ways the orbit fit must respect. Awe and vigilance are not opposites here. They're co-pilots. Keep them both in the cockpit as we fly from what R2 has done into what R2 might do next. The domain where probabilities grow teeth, and the next data point decides which story survives the week. The scariest thing about space is not what we see, it's what our systems are designed to miss. On the 14th of October 2025, with R2 forcing us to care about geometry, cadence, and institutional stamina, the phrase, hard blind spots, stops being a metaphor and becomes a map. This is not about one dramatic rock, it's about how modern astronomy, media, and policy can collectively fail in slow motion, even while each part works as intended. Start with geometry, the first governor of our attention. Sunward approaches hide inside the glare we train most surveys to avoid. Dawn and dusk windows are short, harsh, and fickle. A comet like R2 can spend its most revealing days buried in a slice of sky where exposure time is limited by air mass and gradients, and where a single gust turns a nucleus into an untrustworthy smear. Cause: the object hugs the sun in the sky. Effect: cadence collapses right when physics gets interesting. Instability: signal: a light curve that jumps and stalls as meteorology, elongation, and instrument limits fight over the same minutes of twilight. Next, atmosphere plus instrument coupling. Thin cirrus fakes flats, wind balloons the point spread function, guiding microdrifts shift centroids, saturation creeps in when you push to gain a magnitude. Detectors age, nonlinearity grows, stray light from low angles adds structure that looks astrophysical until a weary analyst calls it out. Cause: the sky changes, and so do our cameras. Effect: residuals swell, outliers multiply, orbit fits wobble at the margins. Instability signal: a solution that breathes too hard when you hold non-gravitational terms at zero and relaxes only when you admit the data aren't as clean as the pipeline assumes. Then, algorithms are under siege. Satellite trains rake the field, cosmic rays spike frames, background models trained on yesterday's sky underperform on today's polluted gradients. We harden thresholds to protect false positive budgets, then discover we buried real signals one bin below. Machine learning classifiers inherit our blind spots. A nucleus tracked at non-sidereal rates may resemble a cosmetic artifact to a model that expects sidereal stars. Cause: defensive filtering. Effect: latency detections that arrive a day late, or never. Instability signal: candidates that appear only after humans break the glass and lower thresholds by hand. Add human plus institutional factors. Rotating staff means rotating memory. Undocumented patches turn into commandments. A veteran who just knows when stray light is lying retires and takes an unexportable heuristic with them. Funding cycles reward new hardware over maintenance. Downtime for calibration loses to time on sky. Cause: organizational entropy. Effect: the same error recurs every few apparitions, only the names change. Instability signal: a subtle repeating bias in astrometry that no one owns because everyone assumes someone else fixed it last year. Finally, media plus public feedback loops. 3I divided by Atlas. Being interstellar dominates novelty. R2, being merely solar system, dominates relevance this week. When coverage follows the shiniest noun instead of the closest operational risk, attention, the one resource we can steer, flows away from the checklist that actually protects satellites, observatories, and crews. Cause: misaligned incentives. Effect: a speculation vacuum that rumor happily fills. Instability signal: a timeline where the first shared plot is a meme, not an ephemeris. This is why the emotion here is systemic unease. None of these blind spots is fatal alone. Together, they stack. Geometry starves cadence. Cadence starves algorithms. Algorithms overfit yesterday. Institutions forget. The public tunes out. R2 is not a villain, it's a stress test. It is showing us, in real time, where probability, instrumentation, and communication part ways. The upright response isn't to panic, it's to accept ownership across the chain and move from worry to work. If blind spots are systemic, responsibility must be systemic too. The cure is not a single miracle sensor, it's a disciplined stack of mitigations that map one-to-one against failure modes, so each weak link has a partner holding tension when the sky, the clock, and the human factor all lean the wrong way. Geometry and cadence mitigation. Build twilight-first habits into survey plans. Schedule dedicated non-sidereal modes at dawn and dusk so fast movers don't smear into anonymity. Expand long baseline handoffs. Stagger observatories by longitude, so the same object is walked across the night in relay. No single site bears all the weather risk. Targeted sunward coverage helps. Modest coronagraphs, UV images with stricter stray light control, and Earth-trailing vantage points to watch where ground arrays avert their eyes. Result: when R2-like objects flirt with the sun, cadence bends but doesn't break. Atmosphere and instrument mitigation. Normalize dynamic thresholding tied to contemporaneous sky metrics, air mass, seeing, cloud cameras, and version those thresholds like code. Treat stray light modeling as a living document, not a rite of passage whispered to new hires. Calibrate nonlinearity monthly. Maintain gold frames to benchmark detector drift. Build a culture where a single clean frame at an awful air mass, taken correctly, outranks 5 pretty frames taken wrong. Result: fewer fake outliers, smaller orbit residuals, less drama when outgassing, adds a whisper push. Algorithms and pipelines mitigation. Train models on non-stationary skies, feed them twilight satellite streaks, non-sidereal fields, so they fail gracefully in the world we actually image. Insert human in the loop, break glass protocols. When priority flags like R2 are active, analysts can lower thresholds within guardrails with automatic audit trails. Maintain a false positive budget that flexes with event priority. Accept more garbage for a week if the cost of a late real detection is high. Result: latency shrinks without inviting chaos. Human and institutional memory mitigation. Pay down maintenance debt. Schedule calibration as first-class science, not optional housekeeping. Archive not just the what, but the why the stray light hacks. The, if you see this pattern, it's weather, not physics law. Pair veterans with juniors. Simulate failure drills, bad flats, clock skew, guiding drift, so muscle memory persists beyond resumes. Result: fewer rediscovered mistakes, faster convergence when anomalies hit. Media and public channels mitigation. Replace novelty bait with operational dashboards, uncertainty cones, ephemerides, cadence calendars, micrometeoroid background estimates. Publish plain language notes when non-gravitational terms enter an orbit. Flag what changed and why. Mention 3IATLAS, only to explain why it's not today's lever. Give audiences something better to share than panic, a plot that teaches them how to read the week. Result: attention pours where it helps toward the work. Here's a one-page systemic risk map you can keep in mind for the next 8 days. Asterisk. Failure mode. Observational signal. Operational consequence. Immediate action. Asterisk. Sunward approach. Sparse cadence near twilight orbit noise grows. Add non-sidereal twilight runs, plus long baseline handoffs. Asterisk cirrus. Divided by seeing, divided by stray light, warped isophotes, centroid drift inflated, residuals dynamic thresholds, plus stray light refit that night. Asterisk model. Over-defense candidates appear late, missed early photometry, enable break glass low threshold lane with audits. Asterisk. Staff rotation, inconsistent reductions, repeat biases, mandatory calibration blocks, plus living documentation. Asterisk. Novelty-driven coverage speculation vacuum, misallocated attention, published dashboards, plus plain language deltas. Thread this back to R2. Its proximity on the calendar, not on the ruler, is where the lesson lives. Over the next week, most outcomes are uneventful at the scale that makes headlines, but uneventful is not uninformative. A shallow uptick in the micrometeoroid background, a stable non-gravitational term in the orbit fit, a tail geometry that refuses to repeat, each is a data point that tells us whether our mitigations are real or rhetorical. Systemic unease is healthy when it translates into systemic discipline. And yes, the responsibility is personal. If you keep time servers tight, you're defending an arc second that decides a residual. If you maintain flats on a windy night, you're defending the credibility of a light curve. If you write the post that shows the ephemeris instead of the meme, you're defending attention, the scarcest safety resource in the room. That's what Tinthuk Trach Neum looks like in a moving sky. Not a speech, but a sequence of small, correct actions that hold even when the story is quiet and the clock is loud. Hold that posture as we step into part 5. We will compare what earns attention with what earns safety, why novelty captures the feed while proximity stresses the system, and we'll quantify the gap so we can close it before the next quiet object decides to grade our homework in sunlight. Welcome to the near-term theatre, where the brightest spotlight chases the loudest actor while the understudy stops the real fire backstage. Tonight's star, once again, is 3IATLAS, a guaranteed ratings magnet with Interstellar stitched across its costume. The scene the ushers keep whispering about is R2, ordinary name, inconvenient timing, and exactly where our attention should sit this week, the 14th of October 2025. If you feel a slow burn of annoyance at that mismatch, good. That's your intuition noticing the stagecraft. The trick isn't malicious, it's mechanical. Media budgets reward novelty, safety work rewards proximity and cadence. Interstellar is a headline. Twilight non-sidereal tracking is a yawn. The feed understands the first word and sells it. The second phrase pays for satellite operators' weekends. That's how we get a timeline where a distant speculative arc elbows out a nearby measurable one, right when a nearby measurable one is how grown-ups avoid surprises. Let's put numbers to the vibe. Think of a risk-relevance mismatch, with 4 practical gauges you can read without a PhD. 1. Proximity, score, time, and geometry. What happens soon in a geometry we can actually observe. R2's answer is, this week, in difficult but doable twilight. 3. IATLAS's answer is, fascinating, uncertain horizon. 2. Operational impact. Could the event nudge micrometeoroid background, force satellite safe modes, or stress radar divided by spectroscopy scheduling in the next 8 days? R2. Plausibly yes, even if subtly. 3. IATLAS. Mostly no, at least not on this clock. 3. Data cadence quality. Are we getting nightly comparable measurements that tighten an orbit, refine afro, and test non-gravitational terms? R2. Yes, with effort. 3. IATLAS. Episodic, often inference-heavy. 4. Uncertainty decay. Is the cone of uncertainty shrinking fast enough to inform real-world decisions? R2. Progressively, as more photons land. 3. IATLAS. Slower, with larger structural unknowns. Measured this way, the rehearsal is more important than the monologue. But the theatre doesn't bill rehearsals, so we edit the set, we crop the ephemeris, and keep the spooky label. We rename near-term risk literacy into buzzkill. Then we wonder why audiences treat space like a haunted house, and not like infrastructure. Here's a modest proposal for your own media hygiene. Run incoming stories through a 1-minute risk audit. If the piece offers a plot without an ephemeris, a worry without a time window, or a claim that spikes emotion while starving you of cadence, dock points. If it gives you a practical, what to watch this week, checklist phase angle, twilight windows, meteor networks, updated non-grav parameters, promote it. Think of attention as a safety budget. Spend it where decisions live. None of this means 3IATLAS is irrelevant. It means the billing order is wrong this week. Interstellar mysteries are wonderful for the long arc of curiosity. Near-term geometry is where responsibility lives. If a newsroom can juggle both, applause. If it can't, give the microphone to places that can. Your share, your click, your comment, that's an editorial vote. Cast it for the story that pays the week's bills. We'll keep the sarcasm gentle, because the fix isn't complicated, just unglamorous. Replace, could this be the end? With, what does cadence tell us by Thursday? Replace scientists stunned with uncertainty dropped from X to Y. Here's what that changes. Replace Interstellar with here is where R2 matters to ops. The internet is allergic to context until someone feeds it patiently, repeatedly, until the allergy fades. which is where we take a breath and get practical, because irritation without a lever is a mood, not a plan. The lever, as always, is a short checklist you can use tonight. Start with a risk-equity checklist, 5 items that rebalance coverage toward the thing that actually carries weight this week. 1. Clock first. What occurs within 8 days? If it isn't in that window, it doesn't get top billing over something that is. 2. Geometry. Second, can the object be observed without heroics? Twilight is hard but real. Coronagraph fantasy is not a plan. 3. Cadence third. Are we seeing comparable night-to-night data? If yes, we can steer. If no, store the hype until the cadence exists. 4. Ops fourth. Does this alter satellite posture, radar tasking, spectro slots, or meteor array thresholds? If yes, it earns column inches. 5. Uncertainty. Finally, show the uncertainty decay. If the cone shrank today, the public deserves to see it. If it didn't, say so and move on. Now, let's name the moves that tilt stories off course. The media bias playbook, lightly annotated so you can spot them in the wild. Asterisk shiny object substitution. Swap a nearby measurable comet. R2 for a distant, mysterious one. 3I divided by Atlas, because the latter headlines cleaner. Asterisk screenshot without scale. Share a dramatic image minus phase angle, exposure, or rate, guaranteeing misread morphology. Asterisk single frame theology. Treat one night's brightening as destiny. Ignore forward scattering, then pivot to a new myth tomorrow. Asterisk uncertainty amnesia. Report a number as fixed. Ignore that non-gravitational terms may enter, then blame scientists for changing a model they explicitly said would change. Asterisk cadence blindness. Quote, the most exciting data point, exclude the least exciting trend. Asterisk interstellar incantation. Append interstellar to goose engagement, even if operational impact this week belongs to a native comet. If you're a creator or editor, here's the antidote near-term storybones you can drop into any segment about R2 right now. Asterisk where divided by when. Tonight's geometry puts R2 at low elongation after dusk. Non-sidereal tracking recommended. Next, clean window, 24 hours. Asterisk what to measure. Photometry and RIPES and G for Afro. Narrowband. C2 divided by OH if available. Watch for a stable wedge suggesting event. She was distracted. Asterisk what could shift. If a small non-grav term, a 1 divided by a 2, stabilizes the residuals, expect ephemeris update. Uncertainty cone should shrink by range with 3 good nights. Asterisk operational note. Micrometeoroid background, negligible to low, but meteor arrays are on alert for a time-locked uptick. Satellite teams reviewed safe mode posture. Asterisk how to close. No catastrophe forecast. Competence drill in progress. Next update at time, with raw counts and fit deltas. Why be this prescriptive? Because fairness in risk perception isn't a vibe, it's a format. The audience isn't allergic to nuance, they're allergic to being played. Give them a way to separate stakes from sizzle, and they will. And if a piece still wants to lead with 3I divided by Atlas today, make it earn the lead. Tie the interstellar arc to what R2 teaches us this week about detection, cadence, and non-gravitational nudges. If it can't do that, it's lore, not news. There's a cleaner way to hold both stories without losing the week. Think of 3I divided by Atlas as the long exposure, the canvas, where we learn patience and humility across months. Think of R2 as the short exposure, the frame where we practice timing, calibration, and communication. The camera needs both modes. The mistake is using long exposure language to narrate a short exposure problem, then blaming the sky for our motion blur. So here's the call, with the sarcasm dialed down and the responsibility dialed up. Editors, pair every mystery paragraph with an ops paragraph. Creators, publish the ephemeris table under the thumbnail. Readers, reward plots, not vibes. When a post hands you uncertainty decay and a what changed since yesterday, note, share it. When it hands you adjectives without a clock, let it scroll into the ocean. If we do that for 8 days, if we give R2 the lane it's earned and let 3I divided by Atlas keep its rightful place, as the long arc will have done something rare on the internet, will have matched our attention to the timeline that matters. That won't trend. It will, however, make the next week quieter for the people who actually keep the sky safe. And that, in a near-term theatre full of fog machines, is the only special effect worth paying for. 400 kilometers is the altitude of the ISS. It is also how close one object skimmed past us this year. That is the sentence that resets the room. We call it 2025 TF in the logs. Not because it was glamorous, because it was fast, dim, and rude, arriving from a sunward sector we barely sample, then knifing through the atmosphere's edge before most people finished breakfast. Range, roughly the ISS lane. Relative velocity, high enough that dodge was fantasy. Notice time, measured in hours, not days. It left no crater, no trending, #only a spreadsheet, that made a few analysts sit very still. Here is the anatomy of that near miss. The first detection wasn't a postcard, it was a packet. A handful of astrometric points with fat uncertainties, taken in ugly air mass at dawn. The pipeline wanted to throw them out. The human in the loop did not. A second observatory added a chord 90 minutes later. Suddenly, the motion was solved. Not elegantly, just enough to trigger the break glass lane where thresholds drop and phone trees wake up. The sky did its part too. Thin cirrus wandered, the guiding fought. A satellite train raked the field. You don't get cinematic clarity on days like this. You get barely enough. Contrast is the teacher. A well-behaved NEO at 35,786 kilometers, geosynchronous altitude, gives you time, geometry, and options. 2025 TF did not. It came in low against the sun, at a phase angle that punishes SNR, with a rate that mocks long exposures. There is no public outreach mode for that geometry. There is only a relay of short non-sidereal frames, unstable seeing, and voices that get very calm on the radio. We always ask the same three questions after a pass like that. What did we see late? Why did we see it late? What hurt because we saw it late? In this case, asterisk, late because the approach hid in the glare. Asterisk late, because pipeline thresholds were set to preserve false positive budgets on a messy week. Asterisk late, because staffing was thin on a holiday morning. None of those alone is a scandal. Together, they shrink notice time, the only currency that buys options. Numbers anchor the humility. An object, 10 to 20 meters across, can carry kilotons of kinetic energy. Chelyabinsk taught that lesson with shattered glass and mutual embarrassment. 2025 TF didn't deposit energy over a city. It didn't deposit at all. That's the point. Near misses are the receipts we keep when reality spares us the invoice. They are also the drills that tell us whether maintenance debt is a metaphor or a hazard class. Hold that feeling as we widen the lens to two more cases that rhyme with this one in quieter ways. First, a twilight grazer, not this week, but recent enough that the team still winces. The discovery image looked like a smudge in a gradient. The second image looked like a better smudge. Threshold said, no. A junior analyst said, maybe. They may have survived long enough to earn a third station's chord. The orbit lived. The object didn't threaten, but the process did. We learned how close a defensible threshold can come to becoming a blind spot when satellite streaks spike and the sky refuses to cooperate. Second, a mini-swarm fragments from a cometoid that sneezed, then shrugged, then moved on. No single piece justified a headline. Together, they raised the micrometeoroid background for a few hours along a predicted node. Radar saw nothing. Meteor arrays saw a whisper counts a little higher than noise, a little lower than comfort. Ops teams didn't panic. They turned panels, checked modes, and waited. That is what competence looks like in the absence of drama. Quiet posture changes that matter precisely because nobody outside the room will ever clap for them. All three cases share a moral that serves us on the 14th of October 2025. While R2 trains the week's attention, you do not need impact to grade readiness. You need compressed time plus awkward geometry plus human limits. Put them together, and the mirror appears. It does not ask for fear. It asks for discipline. Let's put structure around that discipline so it travels. Consider a near-miss triage you can apply to any alert in under a minute. Asterisk range. How many Earth radii, ISS lane, to 400 kilometers, is a different animal from GEO, 35,786 kilometers, on the other lunar distance scale. Asterisk relative velocity. Low gives a margin. higher erases fantasies. Asterisk, notice time. Hours? Days? Weeks? The graph bends at 72 hours. Under that, logistics dominate. Asterisk, sky sector. Sunward twilight versus midnight dark. Twilight steals photons, midnight gives them back. Asterisk, operational impact. What toggles in the next 8-24 hours? Satellite attitudes, radar tasking, spectroscopy slots, meteor thresholds. Run 2025 TF through that filter, and you understand the hush in the control rooms. Range, brutal. Velocity, unfriendly. Notice, tight. Sector, sunward. Ops, posture change, recommended. No doom, no theatrics, just work. There are 3 layers of hazard that near misses keep pointing at, even when nothing hits anything. 1. The body layer. The parent object that gets a designation, a light curve, and a place in the database. It teaches us geometry and timelines. 2. The debris layer. Fragments and flake-offs that change morphology, tweak fits, and sometimes raise background risk without headlines. 3. The background layer. The quiet creep in micrometeoroid flux that doesn't care about our story beats but does care about panel angles, thermal blankets, and sensor glass. If you're a viewer who wants to read the week like a practitioner, while R2 takes center stage, use 3. If divided by then rules, asterisk. If uncertainty cones continue shrinking while afro flutters and narrowband lines, C, 2, O, H, persist, then treat the parent as active but predictable. Watch for non-grav terms entering the fit. Asterisk. If meteor arrays report a time-locked uptick consistent with R2's dust plane, while satellites note a temporary posture change, then you're seeing the debris layer nudge reality without drama. Asterisk. If an alert arrives with high velocity, sunward sector, and notice is less than 24 hours, then read the update like an ops note, not a myth. Posture, cadence, residuals, skip the adjectives. Humility is the through line. After 2025 TF, the post-mortem didn't blame the sky, it tuned the stack. Twilight non-sidereal runs became mandatory on flagged days. Dynamic thresholds got version numbers and audit trails. A golden frame set 1 nasty field per quarter was added to keep pipelines honest about gradients. A stale cron job that pushed flats at the wrong hour was retired with quiet ceremony. None of that makes a thumbnail. All of it buys us minutes next time, and minutes are oxygen. Where does 3I divided by Atlas belong in this chapter? Exactly here, as a control, the reminder that novelty can be a decoy when near-term geometry is what pays the bills. Interstellar arcs deserve curiosity and patience. Near misses demand procedure. The irritation you feel at the mismatch is not cynicism. It is risk literacy trying to be born. Which brings us back to the 14th of October 2025, and the week R2 grades our homework. Most likely, nothing remarkable will cross a skyline. That outcome is not trivial. It is the target. Getting there means treating every quiet pass as a rehearsal, every fidget in the micrometeoroid background as a memo, every stubborn residual as a reason to check a cable before you change a model. It means accepting that our best days are the days nobody remembers because nothing broke. So hold 2 truths as we roll into the next part. 1. Near misses are data, not near stories. 2. Data grows character only when someone does the unglamorous work, lowering a threshold with a note, writing a post that shows the ephemeris table, calling the junior analyst back to say, "Good catch." That's how you convert from shock to earned caution and humility that last longer than a scare. That's how you exit the reality check with something sturdier than a memory, a system that will remember for you the next time the sky arrives an hour early and expects grown-ups to be in the room. A comet doesn't have to hit you to hurt you. It can explode into a shotgun blast that wraps itself along its orbit, turning a single body into a traveling field of sand and shrapnel quiet today, consequential for years. That is the hazard class we need to name out loud this week, the 14th of October 2025, while R2 sits on the calendar and reminds us that planetary risk is not only about rocks and craters, it's about streams. Think of fragmentation in 3 scales. At the macro scale, a comet splits sometimes cleanly into large pieces, sometimes messily into gravel and dust. At the mesoscale, those fragments spread along track under tiny but relentless forces, gravitational tides, sunlight pressure, outgassing thrust, and the slow break of Poynting-Robertson drag. At the microscale, the detritus becomes meteoroids, each grain obeying a different ratio of radiation pressure to gravity. We give that ratio a simple name, beta. Big, heavy grains have beta near zero and stick to the parent's road. Fine grains have higher beta and drift outward, thickening the down-sun glow and lengthening the danger window. If you want a laboratory picture, open the Atlas to Shoemaker Levy 9SL9. Tidal forces at Jupiter tore the nucleus into a string of pearls. The impacts in July 1994 proved the premise no one wanted to prove. Fragmentation is not theoretical melodrama, it is mechanics with a calendar. Earth hasn't hosted that show lately, and we'd like to keep it that way, but the lesson scales. Fragments separate, streams form, the consequences last longer than the headline. Now flip to 73p, divided by Schwassmann-Wachmann 3. It didn't just split once, it keeps splitting. The result is a family of fragments and a trail that can, in the right geometry, inflate a meteorate for a handful of hours. You don't need a catastrophic storm to feel it. A modest encounter can inject enough micrometeoroids to matter for satellites, thermal blankets, and optics that never signed up to be sandblasted. The atmosphere protects people on the ground. It does not protect hardware in space. Here's how the stream physics ties to operations. Fragmentation seeds the orbit with particles of mixed beta. Over months to years, the synchrones, lines, of equal ejection time, and syndynes, equal, beta, spread into a ribbon, thick near the parent's path, wispy at the edges. Nodes, the points where that orbital plane crosses Earth's, become the dates to watch. If Earth passes near the node when a fresh dust sheet has drifted into alignment, meteor arrays see a time-locked uptick. Satellite operators review safe modes, radar experiments set expectations, and the public yawns, which is the correct reaction when competence is winning. Where does that put R2? Not in the panic column, in the non-zero column. If the nucleus stays intact, the week becomes a study in coma chemistry and tail geometry. If it burps a small outburst, the stream gains a thin sheet. If it sheds a real split, the orbit inherits a train of pieces with their own dust, and the calendar inherits a set of maybe dates when Earth might skim a richer slice of that ribbon. This is not doom. It is homework. To turn awe into policy, we have to talk evolution. Fresh fragments don't float in chaos. They organize under simple rules. Large chunks trail or lead the parent by minutes to days initially, then by degrees of mean anomaly as the seasons of an orbit tick by. Dust fans out faster, shaped by beta and by the phase angle during ejection. Is the vent sunlit? Is the jet favoring a direction? Closer to the sun, gas drag and radiation pressure dominate fine grains. Farther out, gravity returns as the quiet accountant. Over time, the Poynting-Robertson effect steals a whisper of angular momentum from small particles, making them spiral sunward. Resonances with planets can shepherd certain sizes into clumps that persist. None of this requires drama. It requires patience. Historical case studies teach us to respect the quiet years. The Jacobinids, Draconids, are famous precisely because they can be boring for decades and terrifying for a night. Depending on whether Earth intersects recent ejector sheets from their parent comet, the geometry sets the hour, the age of the sheet sets the intensity. That is the operational mindset we need for R2, not will we be hit, but what age of dust could we encounter, and when? Now, how do we measure a risk that hides in scales? We marry imaging to timing. Imaging, because synchrones divided by syndynes overlays tell us whether the tail morphology demands recent ejection. Timing, because meteor arrays and infrasound let us mark whether the sky is quieter than yesterday. Layer on orbit fits that include a small non-gravitational term. If the residuals shrink when A1 divided by A2 divided by A3 are allowed, recent activity is not a rumor, it's an input. Layer on node analytics. When do we cross the comet's orbital plane, at what distance, and with what lead divided by lag to any recent outburst? The risk categories then write themselves. Asterisk. Category A. Parent intact, low dust, ordinary background. Watch. Don't fret. Asterisk. Category B. Burp level outburst, thin sheet, narrow time window. Possible minor uptick for meteor watchers. Satellite ops take note, not action. Asterisk. Category C. Fragment shed, multiple condensations, persistent wedge in the coma, afro elevated. Non-grav terms stabilize orbit fits. Stream gets richer. Schedule watch windows around node times in the coming months to years. Asterisk Category D catastrophic breakup, rare. Swarm dynamics, obvious chain in images, third-party confirmations, telemitted dust signature. Operational posture tightens, even if no direct Earth intersection is predicted. For R2 this week, the honest forecast is A trending toward B, with C a small but non-zero tail. That phrasing matters. We are not wishing for drama, we are pricing it, and the price is paid in preparation, not in adjectives. Operationally, here's the checklist that merges physics with practice. 1. Spectroscopy plus photometry. If C2 divided by OH remains stable while Afro grows, favor dust-heavy activity. Watch for coma, wedges that point to vents. 2. Orbit solutions with non-grav terms. Publish the delta. If adding A1 divided by A2 prunes residuals, document it in plain language so public dashboards don't fuel conspiracy theories. 3. Node and moid tracking. Post the next plane crossings. Even if the moid is large, no encounter expected is still useful. 4. Meteor arrays and radar. Pre-brief on time-locked upticks. Define what counts as signal versus weather versus instrumentation. 5. Satellite posture. Review panel angles, safe mode triggers, and graceful degradation steps. These are cheap on quiet nights and priceless on noisy ones. None of this drags 3i divided by Atlas into the center ring. If we mention it, it's to keep our ethics straight. Interstellar is a beautiful plotline, not the operational one this week. R2 earns the clipboard, because proximity and timing write the rules of the next 8 days. Reasonable fear becomes adult action when you zoom out to the orbit scale. Streams are not single nights. They are slow storms written in celestial mechanics. Once seeded, a stream can matter for years, not as a catastrophe, but as a background risk that rises and falls with where Earth is on the calendar and where the dust is on the ribbon. That is why a non-event now can still be a memo for later. Let's run the what-ifs cleanly. If R2 does not fragment, we log a week of chemistry and tail dynamics, refine our non-grav priors, and move on smarter. If R2 burps, we mark the ejection date and model a thin sheet marching along the orbit. That gives meteor watchers a reason to circle specific hours, months out, when Earth could intersect a diluted but noticeable layer. If R2 sheds a child, the calendar gains checkpoints, subsequent perihelia, node passages, and Earth's seasonal alignments, where the probability of a measurable uptick becomes worth a briefing. None of these branches predicts a headline you'd fear. All of them predict work you should respect. The satellite angle is where fear often over- or undershoots. Whipple shields and design margins exist for a reason. Most micrometeoroids are too small to ruin your day. But attitude and timing matter. A modest forecast increase in flux, even a small one, can persuade an operator to adjust a panel orientation, delay a sensitive maneuver, or schedule an instrument cover. Those are tiny choices that turn non-zero into no problem. That is what reasonable fear buys you when you spend it on the right shelf. Communications should follow the same ethic. Replace storm with stream encounter potential. Low, time-locked. Replace mystery object with recent activity observed, non-grav term updated, node dates posted. If there is nothing to see, say so. If there's a thin reason to look, say when and how. Publish the uncertainty and the assumptions. This isn't just better science. It's better trust hygiene in a week where rumor wants to rent the room. And what of the public's emotional arc? Let it be educated caution, not theatrical dread. Remind people that SL9's violence happened at Jupiter, not here. That 73P's drama is mostly a lesson in patience, not panic. That radar and meteor networks exist precisely to turn unknown unknowns into known smalls. Remind them that being impressed by streams is a sign of understanding, not weakness. The sky is a machine that writes in probabilities. Your job as a citizen is not to predict a single night, but to support the culture that watches every night the same way, calmly, competently, and with receipts. So here is our closing posture for the 14th of October 2025. R2 is a teacher, not a threat. Fragmentation is a syllabus, not a prophecy. The shotgun metaphor helps only if it pushes us to map pellets into synchrones, pellets into beta, pellets into node clocks, and ops notes. Do that, and proportionate concern turns into quiet power, the power to aim attention where it pays off, to harden systems without drama, to let a weekend with nothing spectacular and still call it a win. The orbit is long. Our patience has to be longer. Keep your eyes on the ribbon, your charts on the nodes, and your language on the side of adults, and you'll be ready for the next time a comet decides to grade humanity, not with a crater, but with a thin, glittering curve of dust that only looks like nothing until you know how to read it. When official silence stretches, the internet does not wait, it fills. The human brain hates a vacuum. If institutions don't feed it with accountable updates, rumors will. This is the economy of attention on the 14th of October 2025. R2 is on a short clock. 3I divided by Atlas is on a long leash, and the public sits between a drip of real data and a flood of confident guesses. Defensive skepticism isn't cynicism here, it's hygiene. Let's name the cycle so it loses power. Rumor life cycle. 5 beats. 1. Ambiguity. A fragment of information, new observation pending, orbit updating, lands without context. 2. Projection. Creators backfill motive. They're hiding it. It's interstellar tech. 3. Amplification. Screenshots outrun sources. Shares outpace retractions. 4. Mutation. The claim splits into variants. One about danger, one about cover-ups, one about someone's insider cousin. 5. Fatigue. Audiences burn out, then reward the next spectacle with even lower standards. To survive that cycle, build a claim triage you can run in 10 seconds. Asterisk. Tier 1 physics claims. R2. Fragmented, non-gravitational term entered the fit. Micrometeoroid background up. These have measurable hooks, images, residuals, counts. Asterisk. Tier 2 interpretation claims. This means satellites are at risk. This is a storm tomorrow. Requires range-bound language and explicit uncertainty. Asterisk. Tier 3 motive claims. NASA is hiding X, because Y. High heat, low data. Park until evidence exceeds adjectives. Occam's razor lives between Tier 1 and Tier 3. Prefer hypotheses that require fewer new entities, outgassing over alien thrusters, forward scattering over impossible physics, pipeline thresholds over secret cabals. Not because secrets are impossible, but because ordinary mechanisms fit the evidence and the incentives we can actually observe. Here's a burden of proof map for the week. Asterisk. Extraordinary claims, engineered objects, imminent danger, cover-ups, require extraordinary, auditable evidence. Raw frames, calibration notes, independent replication, timestamps that align with known observation windows. Asterisk. Ordinary. Claims non-grav terms, minor outbursts, node dates, require ordinary evidence. Posted ephemerides, clearly explained deltas, consistent photometry. To help your attention budget, use the 5-question test on any post before you share it. Who collected the data? What instrument and mode? When UTC, not vibes. Where sky position divided by elongation? How do you know links to raw or reduction notes? If any answer is a shrug or a screenshot of a screenshot, park it. 2 more heuristics keep you sane. Asterisk. Signal versus spectacle. Signal arrives with cadence and degrades gracefully under scrutiny. Spectacle arrives as a spike and withers when asked for raw files. Asterisk. Uncertainty decay. Real stories show the cone shrinking or not shrinking. Fake ones oscillate between "we know everything" and "we can't tell you anything." So, where do R2 and 3I divided by Atlas sit in this framework? R2 lives in Tier 1 and Tier 2 all week. Photometry, narrowband lines, orbit fit updates. 3I divided by Atlas lives in Tier 2 and Tier 3 today. Long arc, many unknowns, massive temptation to infer motive. The fair ask is simple. Match your attention to the tier. Reward updates that attach numbers to the claim and show their homework. Let motive theatre scroll by. None of this denies the public's fatigue. Misinformation doesn't just waste time, it taxes attention and numbs empathy. The cure isn't more adrenaline, it's friction. Tools and habits that slow you down just enough to keep your standards. That's what the second half is for, scripts and checklists you can actually use when the next confident thread appears at 2A. Let's arm you with responses that de-escalate drama and escalate evidence. 1-sentence reply, template, pick one. Asterisk. Source. Raw frames and timestamps please, UTC is fine. Asterisk. If non-grav terms changed, can you show the residuals plot before divided by after? Asterisk. This is a Tier 3 claim, Parked until Tier 1, evidence shows up. Asterisk, extraordinary claim, extraordinary proof. Links welcome. Asterisk, ephemeris, or it didn't happen. 3-step play for hot threads. 1. Deglamorize, rename the claim in boring terms, possible small outburst, threshold change, cadence gap. 2. Reclock, convert drama into a time window. Next clean observation window is tonight after dusk. Expect updated fit into 1-2 observing cycles. 3. Redirect. Point to a dashboard or primary feed. MPC circulars, orbit solutions, meteor array summaries, or choose silence when there's nothing to point to. Use signal-first indicators to decide if a post deserves your oxygen. Asterisk. Provides ephemerides and uncertainty cone graphics, not just adjectives. Asterisk. Names filters divided by modes. Re, G, C, 2, O, H. Non-sidereal tracking. Asterisk. Explains what changed since yesterday in one sentence. Asterisk admits limits. No radar window. Phase angle high. Then states what that implies for confidence. When a thread claims secrecy as proof, remember, lack of public press release is not equal to lack of internal work. The pipeline is technical by design. It creates lag to protect accuracy, not to stage conspiracies. Ask for the paper trail, observation logs, station codes, and reduction notes. If the answer is screenshots of thumbnails, you have your verdict. To protect your own bandwidth, adopt a personal misinformation SOP. Asterisk mute repeat offenders who refuse evidence after being asked twice. Asterisk park claims whose authors won't timestamp or link. Asterisk request 1. Concrete artifact residuals, raw frame, code, gist. Asterisk move on if the artifact doesn't arrive. Curiosity is a renewable resource. Attention isn't. The Occam posture also applies to emotions. Defensive skepticism isn't about never believing. It's about believing last after the easy explanations stand or fall. With R2, the easy path is outgassing plus geometry. With 3I divided by Atlas, the easy path is we don't know enough today to price operational risk this week. Neither posture is apathy. Both are adults. For creators and editors, here's a public clarity kit you can adopt immediately. Asterisk, publish a what changed box under every update. Max, 3 bullets. Numbers, only. Asterisk, show uncertainty decay as a tiny spark line. Asterisk, include a next window line. Dusk, 18 to 45, 1920 local. Elongation x degrees. Rate y, min. Asterisk tag, claims explicitly by tier, so readers know whether they're seeing physics, interpretation, or motive theatre. And for those who still want an interstellar hook today, you can keep 3I divided by Atlas in the story without hijacking the week. Use it as a foil. Here's what long arc curiosity looks like. Here's what near-term responsibility looks like with R2. That comparison teaches risk literacy instead of harvesting clicks. Attention becomes a safety budget again, not a commodity. We end where the fatigue begins, with trust. Trust grows when we can say, we don't know yet, and show the plan that makes yet shorter. Cadence, instruments, thresholds, nodes. It grows when we return next night with a delta smaller cone, stable afro, null meteor uptick, and treat nothing happened as information, not failure. It grows when the public sees that a calm tone is not a cover story. It's a competence display. So on the 14th of October 2025, practice defensive skepticism the way engineers practice safety, with checklists, timestamps, and receipts. If a claim about R2 arrives without them, let it drift. If it arrives with them, reward it, even if the conclusion is quiet. Occam doesn't kill wonder. It protects it from exhaustion. And in a week when the sky is loud with opinions and quiet with facts, that protection is the kindest thing we can give each other. If you're waiting for a press release, you will always be late. By the time a headline lands, the numbers have already crossed 6 desks, 2 databases, and 1 argument about residuals. That gap, the space between technical truth and public language, is where frustration grows. On the 14th of October 2025, with R2 compressing time, it's worth saying out loud, most of what matters this week travels through pipes that were never designed for show and tell. Here is the info lifecycle map for objects like R2. Detection happens first. An instrument pushes pixels, and a human or a pipeline flags motion. Those observations, stamped UTC with station codes and uncertainties, go to the Minor Planet Center, MPC. MPC is a clearinghouse, not a newsroom. It bins measurements, trims outliers, posts circulars, and assigns provisional designations. No adjectives, just rows and residuals. From there, JPL divided by horizons ingests the data, generates orbit solutions, and posts ephemerides you can propagate. If activity is significant, non-gravitational parameters, a 1 divided by A, 2 divided by A3, may be fit to tame the residuals. Again, not a press release, an update to math with a timestamp. Next hop, CNEOS, if and when relevant. CNEOS evaluates impact probabilities and publishes risk pages or sentry notes for NEOs. For a comet like R2 that is not on an impact trajectory, you may see nothing flashy because there is nothing to escalate operationally. Internally, agencies circulate memos, instrument status, radar window feasibility, meteor network posture, satellite ops advisories. Externally, you might get silence not because nothing is happening, but because everything is happening in technical mode. Technical mode has obligations, accuracy, reproducibility, configuration control. Press mode has different obligations, clarity, context, avoidance of avoidable panic. They do not share a calendar. That is the structural reason updates feel slow. The life cycle is built to protect accuracy first. MPC circulars are not written for the internet. Horizon solution sets do not carry metaphors. CNEOS risk pages are conservative by design. When the public asks for an explainer while the orbit is still tightening, the most honest answer is also the least satisfying. Stand by. Cones shrink at the pace of photons. The internet, allergic to delays, supplies its own conclusions, hence, Part 8. Exasperation belongs here, but so does respect. The system works most days because it refuses to skip steps. A detection becomes a candidate becomes a solution becomes a plan. Only then does the plan become a sentence a layperson can use. If you invert that order, you win the hour and lose the week. R2's calendar is reminding us that engineering cultures earn trust by releasing receipts, time-stamped deltas, not vibes. To make that concrete, imagine today's flow. An observer uploads astrometry before dawn. MPC posts a circular by mid-morning. Horizons refreshes elements by early afternoon. An internal note flags a small improvement in fit if a 2 is allowed. Meteor arrays are told to watch a narrow hour tonight tied to the orbital plane. Satellite ops review posture. What appears online? Maybe a terse ephemeris and a handful of community plots. What doesn't appear? A splashy comet panic banner because there is no panic to sell, only work to do. This is also why name-dropping 3IATLAS can be misleading this week. Interstellar arcs make for great long-form, they make for poor near-term operations. The pipeline must stay boring on purpose. MPC horizons, CNEOs, if applicable, internal memos, optional public note. When institutions try to translate midstream, they either undercommunicate and annoy everyone, or oversimplify and feed rumor mills. The right fix is neither silence nor spectacle. It's disciplined plain language transparency that rides on top of the technical cadence without trying to outrun it. So, how do we maintain the rigor while reducing the eye roll? With minimal, routine public clarity notes that acknowledge the calendar without pretending the science is done. 3 commitments, posted where people actually look. 1. What changed? Delta. 3 bullets, numbers only. Cone semi-major shrank from X to Y. Afro steady. A 2, now included in fit. 2. Uncertainty. Spark line. A tiny line showing the cone shrinking, or not, across the last N solutions. No adjectives, just a slope. 3. Next, window, dusk, local 1847-1925. Elongations degrees, non-sidereal rate. R, min. Expect next solution by T, UTC. That's it. Not a press release and SLA for attention. If nothing changed, the note says, no material delta, next check at T. Silence is replaced with a metronome. To decide when a full press product is warranted, keep an escalation ladder that separates technical state from public narrative. Asterisk. Green technical normal. Routine updates at MPC divided by horizons. No CNEO's risk item. Internal memos only. Public clarity note is optional, weekly at most. Asterisk. Amber, technical interest. Non-gravitational terms, stabilize fits, minor outburst confirmed. Meteor arrays on gentle alert, public clarity. Note daily with delta and next window. Asterisk. Red operational relevance. Elevated micrometeoroid background, plausible in a time-locked window. Radar tasking activated. Satellite posture change recommended. Public clarity note per cycle. A coordinated press Q and A after the window closes, emphasizing what was predicted, what occurred, and what changed in the models. For R2 on October 14, the honest posture is amber trending green. Interesting physics, low operational stakes, high rumor pressure. That is exactly the zone where institutions usually go quiet and the internet goes loud. A one-paragraph delta prevents 5 days of speculation. Creators and editors can help by matching their products to the life cycle. Lead with receipts, link the MPC circular, show the horizons element set, annotate the single plot that demonstrates the week's delta. When you mention 3I divided by Atlas, do it to teach contrast. Long arc curiosity versus short arc responsibility. If a source cannot provide the who, divided by what, divided by when, divided by where, divided by how, do you know, park it. If it can, quote it, especially when the conclusion is, nothing happened. Non-events are outcomes, not failures. Internally, agencies can buy credibility with 2 cheap moves. First, publish a glossary light on the same page as the delta. Afro equals dust proxy, a 1 divided by, a 2 divided by A, 3 equals non-grav terms, node equals where orbits cross. Second, adopt version thresholds the way software shops version code. So when someone asks why last night's candidate was buried, there's a changelog instead of a shrug. These are not communication stunts, they are controls that keep both pipelines and narratives honest. And yes, it helps to admit what the system cannot do. Tell people plainly, sunward geometry slows cadence, meteorology eats nights, our false positive budget fluctuates with satellite streaks. When you say that before the rumor cycle says it for you, trust climbs. When you tell them exactly when the cadence will speak again, fatigue drops. The last mile is cultural. Replace the instinct to save an audience from technical detail with the instinct to equip them. A citizen who can read an ephemeris box, however crudely, is harder to scare and easier to serve. A reporter who expects a delta bullet each evening will stop calling at noon for a quote you cannot responsibly give. A creator who learns to plot the uncertainty sparkline will stop mistaking healthy model changes for scandal. That's the tone we're keeping for the next 8 days. R2 does not require a podium. It requires cadence with receipts. If a real operational shift appears, a measurable non-grav nudge, a time-locked uptick in background flux, a radar window that turns from marginal to open the ladder moves, the product changes. Until then, the dignified answer to impatience is a small, on-time box that says what changed, what didn't, and when to look again. You can be tired of waiting, and be fair about why you're waiting. That is what adult communication feels like in a moving sky. Practical, a little dry, occasionally dull, and precisely the kind of dull that keeps people safe. Keep the math in the pipe. Keep the public in the loop, and let the story earn its adjectives only after the numbers finish their run. If R2 were an engineered or actively piloted object, it would have to leave fingerprints, not vibes, signatures. That's how we keep our minds open and our standards high on the 14th of October 2025, by writing down the tests that a claim must pass, then checking what the sky actually gives us. We'll use 4 axes, all falsifiable. Axis 1, spectroscopy. What it's made of. Engineered hardware tends to look grey and featureless in narrowband gas filters. Comets do not. Real comets advertise chemistry. C. 2 bands that paint the coma green. CN around 388 nanometers. OH as the water proxy. Sometimes forbidden oxygen lines if instruments allow. The dust continuum behaves with phase angle, and Afro gives a pragmatic dust production proxy. If R2 were a machine, the spectrum would need to avoid those molecular signatures or fake them consistently across telescopes, nights, and band passes. What do we actually see this season? a playbook of volatile-driven emission plus dust behavior that matches phase geometry. That is not a mic drop. It is a prior that moves our Bayesian slider away from engineered. Axis 2 orbital dynamics. How it moves. A piloted or thrusting object would show coherent, programmable deviations, burn-like impulses, station keeping at unnatural nodes, or maneuvers that respect mission logic more than solar system mechanics. Comets, by contrast, often need a small non-gravitational term to tame residuals, a 1 divided by A, 2 divided by A, 3, from outgassing jets. These terms are weak, sun-facing, thermal cycle-linked, and they vary with activity, not with intent. If adding a tiny A2 stabilizes R2's fit and the direction matches sunward heating cycles, that's coma physics, not a flight plan. If you want piloted, your model must outperform the small, boring shove of sublimation and explain why any advanced vehicle flies a path indistinguishable from fragile ice and dust. Axis 3. Electromagnetic emissions, what it says. Active craft tend to talk. Carrier beacons, telemetry, spectrum with narrowband structure, or radar cross-sections that look metallic and compact. Comets are awful radios. They scatter sunlight and shed gas. They don't transmit. Null radio results don't prove natural origin, but consistent nulls across sensible bands paired with positive detections of molecular fluorescence make the artificial story expensive to maintain. Secret stealth is not an argument. It's an unfalsifiable escape hatch. We don't grant those on principle. Axis 4. Control behavior, what it chooses. If R2 were under control, it would choose geometry that makes engineering sense. Loitering near Lagrange points, pacing Earth at unnatural rates, or executing mid-course corrections that line up with energy-optimal windows. Instead, we see perihelion tide activity, phase angle-driven, brightening, tail structures readable, with synchrones divided by syndines, and cadence that honors sunlight, not strategy. The story in the pixels says thermomechanical, not mission design. Now fold those axes into a Bayesian sketch. Start with a low but non-zero prior for engineered comet, because reality has surprised us before. Ask, how likely are the observed spectra, tail dynamics, non-grav fits, and radio nulls if R2 were engineered? Pretty low, each dataset would need ad hoc excuses. Then ask, how likely are those same observations if R2 is a natural active comet? High. Posterior moves where logic says it should. Occam's razor doesn't ban miracles, it prices them. For audiences exhausted by sensational arcs, here's a 5-question, show your work, test you can deploy before sharing any R2 as a craft thread. 1. Spectra posted? Which lines, which filters, and when? 2. Orbit fits compared? Residuals before divided by after non-grav terms? 3. Signal search? Any narrowband EM hits with timestamps and independent replication? 4. Behavioral claim? Where's the maneuver model that beats outgassing physics? 5. Replicability? Can another team reproduce the plot from raw frames? If a claim can't clear those boring bars, it's not persecution to say, parked. It's adulthood. Let's anticipate and disarm the common pivots that keep conspiracies alive, without dunking on people who are simply curious. Pivot A. The spectrum could be spoofed. Sure, in principle. But spoofing would need to reproduce time-variable gas signatures that track solar heating, respect the comet's rotation, and cohere across instruments and nights. That means faking not just one green coma, but the phase angle modulation of dust, glare, the OH proxy, tied to water sublimation, and the afro drift under changing geometry. At that point, you've engineered a device that perfectly imitates the behavior of porous ice and dust under sunlight. Occam taps your shoulder. Pivot B. Non-gravitational terms prove a thruster. They prove a push, not a purpose. Jets from active vents supply a tiny, sun-facing acceleration with cadence linked to thermal cycles and rotation. A thruster model must name burn times, vector angles, and mission logic, and then outperform the outgassing fit on residuals. If the thrust always points roughly where the sun is and scales with activity, you've rediscovered sublimation. Pivot C. Silence means cover-up. Silence often means technical mode. MPC circulars are dry by design. Horizons speaks math. Many updates are not press products. The fix is not a gotcha. It's public clarity notes, Part 9. What changed? Uncertainty. Sparkline. Next window. If you want to test systems, press for receipts, not for adjectives. A conspiracy that can't survive timestamps and raw frames isn't a conspiracy. It's a plot hole. Pivot D. Interstellar means alien. Sometimes rocks come from far away. Sometimes they don't. 3. I divided by Atlas is a long arc curiosity, not a near-term operational story this week. Even if R2 had an interstellar origin, it doesn't behave like one. That's provenance, not purpose. Origin is a romance. Behavior is a dataset. Now, because we promised falsifiability, here's how the artificial hypothesis could score real points if nature surprises us. Asterisk. A narrow-band EM carrier, recovered independently by multiple stations with matching Doppler behavior. Asterisk. Impulse-like changes in trajectory that fit a burn schedule, not a heat curve. Asterisk. Spectral edges, consistent with alloys or coatings, persisted across phase angles and apertures. Asterisk. A radar cross-section, grossly inconsistent with rubble, paired with a rotation light curve that screams rigid body. If any of those show reliably, we update our priors publicly. Skepticism is not a fortress, it's a hinge. For creators and editors who want to raise the standard without losing the audience, try this anti-sensational script, calm, procedural, and reusable. Asterisk frame. 2 hypotheses. Natural active comet versus engineered, divided by controlled craft. Asterisk evidence table. Spectra. C. 2 divided by Cn, divided by OH versus flat, orbit fits with divided by without, a 1 divided by A, 2 divided by A3, radio nulls versus lines, behavior phase angle divided by vent linked versus maneuver logic. Asterisk delta line. Since yesterday, residuals dropped X%, no radio lines found, afro stable within Y%, tail wedge consistent with synchrones. Asterisk, next window. Dusk, non-sidereal rate R-min, expect updated solution by TUTC. Asterisk. Closure. Artificial remains a low prior testable claim. Natural explains the data with fewer assumptions. Change in. Finally, a word to exhausted readers. You don't have to fight every thread. Adopt a personal SOP that keeps your oxygen for real work. Ask for one artifact, raw frame, residuals plot, EM waterfall. If it doesn't arrive, move on. Curiosity is infinite. Attention is not. R2, on the 14th of October 2025, rewards method. Spectra that talk chemistry, dynamics that talk heating, radio that talks silence. That picture is not dull. It is beautiful, in the way well-behaved. Physics is beautiful, predictable enough to trust, noisy enough to learn from. If a wild card shows up tomorrow, we'll test it on camera, with receipts. Until then, Occam's razor stays on the table not to cut down wonder, but to shape it into something the weak can actually use. Your brain keeps a map of the world, an internal star chart stitched by place cells in the hippocampus and grid cells in the entorhinal cortex. On the 3rd of October 2025, a Stanford group reminded us again what aging quietly does to that chart. The grid gets noisier, the landmarks blur, the map still works, but only if you move more slowly, check the compass more often, and forgive yourself for walking past the right door. If that picture feels human, it should. If it also sounds like a telescope, it should sound even more, because astronomical instruments keep maps too. A camera's plate scale is a grid. A telescope's PSF is a fingerprint. A reduction pipeline's bias frames, darks, and flats are the long-term memory of a machine that would otherwise forget what level ground looks like. As detectors age, the neurons of our system amplifiers, pixels, track algorithms drift in tiny, regular sins. Nonlinearity creeps, hot pixels multiply, stray light learns new tricks. We pretend they don't by borrowing yesterday's calibration and promising we'll rewrite the flat field notes tomorrow. Tomorrow becomes a season, the grid tilts another hair. Neuroscience gives us language for that tilt without self-loathing. In older animals, grid periodicity becomes less precise. Path integration accrues more error per meter. The brain leans harder on external cues to stay on track. Translate that to the dome. Your plate solution eats a little more sky per night than you budgeted. Astrometric residuals carry a swollen tail. You rely more on standard fields and golden frames to snap your internal map back to something an ephemeris can trust. The hippocampus reaches for a landmark. The pipeline reaches for a cluster with well-behaved stars and says, "Anchor me." That's the existential part. The recognition that drift is natural. Both carbon tissue and silicon systems live under entropy. Wires oxidize. Synapses reweight. Documentation ages out of the building when the person who wrote it finds a new job. We want to believe intelligence defeats time. It doesn't. It organizes time. And that is where hope fits, not as a cure, but as a craft. The craft looks boring, which is why it works. You schedule monthly nonlinearity checks the way a clinic schedules cognitive screenings. You keep a version threshold log, so the reason you raised the detection bar last March doesn't die with an email account. You monitor PSF shape as if it were a vital sign, because it is. An expanding PSF is a widening memory. You store golden frames, ugly twilight fields with gradients and streaks, to test whether your model of normal still recognizes the world when the world is inconvenient. You pair a veteran with a new hire and reverse mentor both ways. One teaches institutional memory, the other teaches tooling. This is how a lab buys another season of competence, not by pretending to be young, but by choosing not to be forgetful. Bring it back to the week. With R2 compressing attention on October 14, we can choose impatience. Why isn't the orbit done? Or we can choose a maintenance mindset. The orbit will refine at the pace of photons. Our job is to ensure our map isn't lying when the photons arrive. Neuroscience doesn't make that job romantic. It makes it forgiving. If memory needs cues, then publish the cues. Delta bullet points, uncertainty spark lines, the next window line. Part 9. If the instrument needs a refresh, give it that hour and call it science, not downtime. And if you, personally, need the humility to check the manual one more time, borrow it from a brain that's been doing humble navigation since the first warm animal looked for home at dusk. The Stanford result that hit hardest wasn't that spatial memory degrades, it was that structure remains. The grid doesn't vanish, it loosens. The place cells don't go silent, they hesitate. The same is true of observatories that have seen 1,000 sunrises. The array doesn't fail, it forgets small things, then calls those lapses normal until the residuals get loud. If there is a creed that saves both brains and telescopes, it's this: make the small repairs while they're still small. So write a protocol of care that treats sky mapping like clinical care. Asterisk baseline often. Run a weekly astrometric sanity set and publish the fit like a lab value. Mean error, tail weight, trend. Asterisk. Golden frames on purpose. Challenge the pipeline with the worst field in your archive. Low altitude, gradients, satellite streaks. If the model can't find itself there, it can't find itself when a comet like R2 skims the horizon. Asterisk version thresholds. Every change gets a number and a reason. Lowered detection SNR from 6.0 5.4 during amber posture due to R2 is history. It felt right is weather. Asterisk PSF vitals. Track width, asymmetry, and wings. A brain with swollen noise sleeps badly. A telescope with swollen wings lies about point sources. Asterisk mentorship is memory. Pair people. Archive not just what you changed, but why. A small paragraph written today is an hour saved. The night a near miss shows up at 400 kilometers. Notice how unheroic that sounds. That's the point. The hippocampus doesn't do heroics. It does loops. It runs the environment, trims the weights, tries again. A mature observatory looks the same from the outside. Loops. Observe, reduce, calibrate, compare, adjust, repeat. You don't beat aging, you teach it manners. And there is a gentler hope under the procedures. When neuroscientists cue older animals with stronger landmarks, navigation improves. When we cue our instruments and institutions clearer logs, better flats, tighter time servers, the sky becomes legible again. The map firms up. The world feels less like a rumor and more like a place. That's a moral choice as much as it is a technical one, to prefer the slow restoration of accuracy over the fast release of adrenaline. If you still want a narrative flourish, keep it honest. Let 3IATLAS be the novel you read across a winter, occasionally dazzling, slow, indulgent. Let R2 be the checklist you run this week, short, disciplined, consequential. The brain survives on both modes, so do observatories. Long-form curiosity keeps the culture alive. Near-term maintenance keeps the machines aligned. One without the other is either mythology or burnout. We'll end where the hook began, with a map. Inside your head, grids whisper meter by meter, "You are here." Inside the dome, plate solutions whisper arc-second by arc-second, "The comet is there." With age, both whispers grow hoarse. That isn't a tragedy. It's biology and engineering asking for the same kindness. Don't rush, don't guess, don't skip the check. On the 14th of October 2025, with R2 grading our homework, the kindest thing we can do for our brains and our telescopes is the same. Make the world legible enough that a quiet pass is recorded cleanly, a non-event is celebrated as a win, and the map, however imperfect, still gets us home. If you want certainty, you want faith. If you want the truth, you have to live with probability. That's the rule in medicine, in astronomy, and this week, on the 14th of October 2025, while headlines promise reversal and the sky quietly demands calibration, the public wants a yes divided by no about Alzheimer's. The cosmos offers us percentages about R2. Our job is to keep those instincts from colliding. Start with a picture, not a promise. A bell curve for clinical outcomes, an uncertainty cone for orbits. Both are honest, both are unsatisfying, and both beat the illusion of destiny. Science doesn't do guarantees. It does base rates plus likelihoods. Base rate: how often a thing happens before you learn anything new. Likelihood: how strongly new evidence should move you from that base. If a small early study reports dramatic cognitive gains, you don't jump to reversal. You compute a likelihood. Ratio is this one times the usual noise. 10 times? 100 times? If orbit residuals for R2 shrink when a tiny non-gravitational term is allowed, you don't jump to danger. You update the prior. Interesting physics. Low operational stakes. Watch cadence. Here's a compact kit you can use on any breakthrough or space scare. Asterisk base rate check. What's the historical hit rate? Early Alzheimer's interventions rarely flip cognition. Twilight comets rarely generate operational risk within a week. Asterisk LR ladder 1, 10, 100. How much does new evidence move the needle? A single lab with 8 participants is an LR to 2 story, not 100. One night of photometry is LR to 2 for activity, not for catastrophe. Asterisk. Point versus interval. A point estimate thrills, a prediction interval protects. Ask for ranges, not single numbers. Asterisk calibration strip. Show yesterday's forecast next to today's outcome. Did 60% likely happen about 60% of the time last month? If not, the system is confident, not reliable. Asterisk Briar Mini. Keep a personal score. Forecast. Outcome. Squared. Lower is better. It works for rain, clinical claims, and comet behavior. Use that kit on R2 and on the Alzheimer's headline du jour. The feeling you're left with is the same. Awake and humble. You're awake to possibility, restrained by math. You stop asking for finality and start asking for cadence. What changed since yesterday? What is the next window for better data? What's the interval, not the anecdote? Now build the Hype Firewall 5 questions you can staple under any post before you hit share. 1. Base rate stated? Without it, the rest is theatre. 2. Evidence graded? Pilot versus Phase 3. One night versus multi-night cadence. 3. Interval shown? No range, no respect. 4. Replication path? Can another lab divided by telescope rerun it tomorrow? 5. Decision relevance? What should change this week if true? If a claim fails 3 of 5, park it. Curiosity deserves better than sugar highs. Which leads to the bridge we actually need. AI not as a hype engine, but as the plumbing for probability. The next segment will keep the same discipline and show how modern models help us stay calibrated without selling miracles. AI can inflate hype or deflate it. The difference is calibration. In machine learning, we draw a reliability curve, predicted probability on the x-axis, observed frequency on the y-axis. A perfect model hugs the diagonal. Overconfident models sit above it. Timid ones sit below. Apply that to health headlines and to R2 updates. If we say 70% likely outburst tonight, 10 times, and only 4 happen, we don't need better adjectives, we need better calibration. Two tools matter this week. First, conformal prediction, a way to wrap each forecast in a formally valid prediction interval that adjusts with data scarcity. It replaces, "trust me," with "here's the 90% band." Second, active learning when the system doesn't have enough labeled examples. It asks for the most informative new data. In practice, telescopes schedule twilight non-sidereal runs because that's where uncertainty is fat. Clinicians enroll the subgroup that will collapse the interval fastest. These aren't buzzwords. They're habits that push us toward humility with receipts. Bring it back to operations. For R2, an AI-assisted pipeline can classify frames under ugly gradients, estimate afro with uncertainty, and flag when adding an A, two-term LOPS meaningful residuals. But a calibrated pipeline also knows when not to speak in absolutes. It yields prediction intervals for brightness, jet strength, and sky position. It prints a tiny calibration strip that shows last week's reliability. It pushes a next window line instead of a ta-da. That is how models help humans steer clear of hype while still acting on time. The same ethic belongs in medical reporting. A sober AI-aided summary should surface base rates, map study design to an LR estimate, and present a risk difference, absolute, not just relative. Cognitive composite improved by 2-4 points over 12 weeks. 95% PI 0, 6, in N equals 64, replication pending. It should resist the word reversal, the way orbit teams resist the word doomed. Not because we fear hope, but because hope needs scaffolding. If you're a creator, editor, or just a careful reader, here's a 1-minute probability playbook you can reuse tonight for R2, for Alzheimer's, for anything with stakes. Asterisk, state the prior. Historically rare or common enough to watch. Asterisk, quote the LR. Today's delta looks like a 310 times shift, not 100 times. Asterisk, show the interval. Best estimate plus or minus on a spread. Asterisk, mark the calibration. Last month, our 60% calls hit 58%. Asterisk, tie to action. What should change before the next window? He was struck. Notice the mood this creates. Quieter, sturdier, less viral, and more useful. It is Fongur hype by design, not by scolding. It treats attention like a safety budget. It makes non-events valuable because they shrink uncertainty, and it makes events manageable because they arrive wearing intervals instead of capes. As for 3IATLAS, keep it in the long shelf where curiosity lives. It's a beautiful question, not a near-term lever. R2 is the week's quiz on whether we can hold two truths at once, that science is probabilities, not destinies, and that adults can act confidently inside intervals, not just outside them. If we do that tonight, tomorrow, for the next window, we'll end the week with fewer exclamation marks and stronger systems. That's no less hope. It's a hope with bearings. Picture the first night the Vera Rubin Observatory runs at full stride. The shutter cycles, the focal plane floods, and billions of changing points pour down the wire. No human list is long enough. No editorial meeting is fast enough. If we want to keep up with a sky that rewrites itself every few nights, AI has to draft the first version of reality, and we have to draft the first version of AI. 14th of October 2025 is not the future, it's the on-ramp. Large context, multimodal models released this month promise to read images, tables, and time series in the same breath, while classic astro-tooling leans on machine learning for the dirty work, cleaning cosmic rays, linking detections, classifying transients, refining orbits when non-gravitational nudges whisper through the noise. R2 is our weekly quiz. 3IATLAS is the long novel on the nightstand. The pipeline must serve both curiosity and operations without trading rigor for reach. Here's the Astro AI Pipeline v2025 in 7 layers, each with inputs, models, metrics, and failure modes, and the point where a human can and should step in. 1. Ingestion pixels candidates. Asterisk inputs, raw frames, calibration sets, bias divided by dark, divided by flat, telemetry, seeing, air mass, sky, brightness, observatory logs. Asterisk models, denoising diffusion filters tuned for astrophotography, cosmic ray rejection networks, star divided by galaxy, divided by comet separators, image differencing with learned kernels that adapt to PSF changes. Asterisk metrics, false positive budget per hour, latency to candidate, PSF fidelity, throughput cost. Asterisk. Failure modes, satellite streaks mimic motion, gradient mismodeling, PSF drift, overcleaning that erases real features. Asterisk. Human handoff. Golden frame, sanity checks each week, override lane to reprocess with stricter, divided by looser kernels. 2. Quality control, QC. Asterisk inputs, candidate cutouts, metadata, and environmental monitors. Asterisk models, anomaly detectors, temporal transformers, outlier explainers that highlight pixels driving a decision, calibration drift alarms. Asterisk metrics, calibration Breyer score, rate of human overrides, time to acknowledge anomalies. Asterisk. Failure modes, confirmation bias, the model trusts last night's sky too much, spurious alarms on thin cirrus, silent failures when telemetry is stale. Asterisk human handoff, QC dashboard with show your work, overlays, one-click request for raw frame re-ingest. 3. Association divided by linking, who is who, across time. Asterisk inputs, detections across visits, prior ephemerides, non-sidereal tracking info. Asterisk models, probabilistic trackers, graph neural nets for cross-night linking, differentiable ephemeris solvers that allow gradients to flow from orbit, fits back to association. Asterisk metrics, link purity divided by coverage, missed link rate under twilight geometry, compute per link. Asterisk failure modes, object confusion at low elongation, duplicated tracks, orphans that never get linked. Asterisk human handoff, a candidate zoo where humans fix hard cases and feed them back as active learning seeds. Classification, what kind of thing is this? Asterisk inputs, image stamps, light curves, colors, spectra, when available, contextual catalogs. Asterisk models, multimodal foundation models, few-shot adapters for rare classes, for example, cometary fragmentation versus asteroidal flare. Calibration layers to keep probabilities honest. Asterisk. Metrics, precision divided by recall, reliability curve, slope, calibration, cost per classification, abstention rate, knowing when to say, I don't know. Asterisk. Failure modes, overconfident mislabels in novel skies, domain shift, twilight versus dark time, bias against faint, fast movers. Asterisk human handoff, grey bucket, routed to expert review, model learns from marked up mistakes. 5. Orbit refinement, math meets pixels. Asterisk inputs, astrometry streams, photometry, dynamical priors, non-gravitational templates, a 1 divided by, a 2 divided by, a 3. Asterisk models, hybrid physics ML, classical orbit solvers wrapped in neural surrogates for speed, conformal prediction to attach valid intervals, differentiable residual models that test whether adding non-grav terms is evidence or overfit. Asterisk, metrics, residual reduction, interval coverage, time to converge, changelogs. Asterisk, failure modes, spuriously discovering non-grav pushes when calibration is off, hiding real pushes by over-smoothing, math, divided by ML handoff bugs. Asterisk, human handoff, buttons labeled show residuals before divided by after, toggle A. 2. Compare to last clear night only. Zix, event orchestration, what should happen next? Asterisk inputs, ranked candidates with uncertainties, observatory availability, weather, satellite ops posture, radar windows, meteor array readiness. Asterisk models, bandit schedulers that value information gain, cost-aware planners, active learning to pick the most informative next look. Asterisk metrics, information gained per hour, opportunity cost, number of unnecessary follow-ups avoided. Asterisk, failure modes, chasing spectacle, starving low signal but critical lanes, cascading bias when one bad assumption feeds the planner. Asterisk, human handoff, veto power, explain my plan panel to justify each scheduling decision. Public divided by operations products, what we publish. Asterisk inputs, everything above, condensed. Asterisk, models, summarizers, constrained by policy templates, delta bullets, uncertainty, sparkline, next window, no speculation unless flagged. Asterisk metrics, clarity score from reader studies, rumor suppression lag, frequency of corrections, asterisk failure modes, over-smoothing nuance, anthropomorphizing a model, drifting into hype language, asterisk human handoff, editor in the loop, red team for phrasing before public release. The hope lies in the fact that each layer makes the others better. An ingestion fix cleans QC, a linking correction tightens classification, a principled interval keeps operations honest. The warning sits right next to it. Bad assumptions also travel. If the star tracker's time server drifts, an elegant transformer will mislearn cleanly. If the dataset is skewed toward dark sky visits, twilight objects like R2 will be misscored in the hour that matters most. So we write down guardrails before the fireworks. Fail closed, abstain, when confidence drops below a threshold. Flag domain, shift twilight, high air mass, explicitly. Log costs alongside performance, and publish calibration plots with the same dignity we give accuracy numbers. Hope is a plan with receipts. The headline promise of October 2025's models is long context and multimodality. For astronomy, context isn't just words, it's nights, strings of images, where the meaning of frame n depends on n1 and n+1. It's also modes, the same object seen in G-primed and Rho-primed in narrowband, C2, in a noisy spectrum after midnight, plus a handful of radar pings and a meteor log that looks like nothing until it doesn't. A model that can hold all of that in memory, ask for the next most informative thing, and explain itself in operational English is not a luxury, it's how you turn a flood into a flow. Let's pin the tech stack to live tasks. Object classification with humility. A multimodal classifier takes an image stamp of R2, a short light curve, a note that the phase angle is high, and a hint from last night's AFRO estimate. It outputs a distribution, not a verdict. Active comet, 0.78, dusty asteroid 0, 12, other 0.1. A calibration layer adjusts those numbers to match reality. If the model historically overcalls active comet at twilight, it learns to underdraw in that domain. The abstain channel matters most. Uncertain, please get narrowband C2 within 24 hours. That's not a weakness, it's a plan. Orbit refinement that respects physics. A hybrid solver handles the math, but it's wrapped in a neural surrogate that approximates expensive pieces so we can iterate in seconds, not hours. When the residuals shrink only if A2 is allowed, the UI shows the delta, and the model prints the assumptions. Assuming thermal cycle-linked outgassing, no burn-like impulses detected. If the user clicks "Compare to last clear night," the system drops frames contaminated by poor seeing or clouds, and recomputes to avoid discovering a force field in calibration noise. Speed without confession is hype. Speed with confession is a tool. Transient scanning in real time. Rubin-class cadences create an ocean of transients. Supernovae, variable stars, flare stars, minor planet flukes, instrumental ghosts, and occasionally the kind of cometary outburst we care about this week. Temporal transformers read sequences like sentences. If a tail wedge repeats as the nucleus rotates, the model knows the grammar and pings a jet hypothesis. If a brightening aligns with phase angle changes and forward scattering, it leans toward geometry, not physics. The point isn't to be perfect, it's to be fast and calibrated, so that humans spend time where the frontier actually is, preparing for the Rubin fire hose. Every few nights, the southern sky will refresh. The pipeline must survive 3 predictable shocks. Asterisk, volume shock, billions of detections, hundreds of thousands of candidates. Solution, cost caps per layer, anytime algorithms that give rough answers when compute is scarce, and refine when slack appears. Asterisk, domain shift shock, weather, twilight, lunar phase. Solution, explicit domain tags, per domain calibration, shift alarms that slow the system and raise the abstain rate when the sky departs from training. Asterisk novelty shock, something the model hasn't seen. Solution, novelty detectors with human request buttons, rapid active learning loops, where an expert's 2 minutes buys the model 200,000 saved minutes tomorrow. All of this sparks the ethical questions we cannot outsource to code. Alignment for a sky machine. We like to say AI should be aligned. With what? In astronomy, alignment targets are concrete. Safety, don't suppress rare but important alerts. Fairness, don't starve low-resource observatories of relevance. Truthfulness, don't invent confidence. And resource stewardship, don't burn the budget to chase spectacle. These goals conflict at the edges. A model that reduces false positives may raise false negatives on fast movers at dawn. A model that equalizes attention to smaller telescopes may slow the global best response. Writing down the trade-offs and publishing them is part of alignment. Otherwise, alignment becomes a vibe, not a policy. Governance and audit trails. When a model suggests lowering a detection threshold during an amber posture, Part 9, it should file a change request with a reason, a scope, and an automatic rollback if the override duration expires. When it summarizes results for the public, it should follow the delta divided by uncertainty, divided by next window template, and attach the plots so readers can check the math. When it fails, because it will, the root cause analysis should be shared, not buried, especially if the failure was interesting. In short, treat the model like a junior colleague with perfect memory and no pride. Data rights and community norms. Rubin, community surveys, amateur networks, satellite operators. Not everyone plays under the same license. A foundation model trained on a mixed buffet of public, restricted, and citizen science data must respect consent, attribution, and revocation. The fastest way to poison public trust is to ingest without asking or to summarize without credit. The fastest way to build it is to put contributors in the loop and give them useful returns, local alerts, clean dashboards, and public recognition when their observation moved the needle. Dual-use risk. A system that can spot exotic transients can also prioritize assets for bad actors. A model that reduces false positives can be misused to hide real signals. The answer is not secrecy. It's layered access, rate limits, and red teaming. Let friendly adversaries try to break your alert filters before strangers do. Publish your threat model. Silence on dual-use risks reads like denial. Against that sober backdrop, the hope gets stronger, not weaker. A calibrated, governed, humble AI can make the sky feel closer and safer, not by predicting miracles, but by making ordinary nights legible at scale. It frees scientists to think and the public to breathe. It turns R2 from a stressor into a teacher. It makes 3I divided by Atlas a long conversation, not an attention trap. Let's walk a night in the life with R2 as the pipeline's test case, so the promise and the cautions are concrete. 18 Local Pre-Brief. The weather is marginal at dusk. The planner displays 3 lanes. A. Twilight non-sidereal run on R2 for 15 minutes. B. Wide-field meteor array watch synchronized to the orbital plane clock. C. Spectroscopic slot. Gamble if seeing improves. The model advises E. Abstains on C, with a note. Phase angle high, SNR unlikely, cost heavy. A human signs off but tags a backup. If seeing is less than X by 19, flip to C for 1 exposure. 19.5 ingestion plus QC. Frames stream in. Diff kernels adapt to an ugly PSF. Satellite streaks cross 2 exposures. The system flags them and salvages half the field. A faint wedge in the coma appears. The classifier prints active comet 0.74 plus or minus 0.12, and more importantly, request narrowband C2 within 24 hours. Jet hypothesis, medium. QC overlays show which pixels bent the needle. A junior analyst says, looks real. The model logs the comment and boosts the weight of that region for the night. 1920 association plus orbit. Linking matches tonight's detections to last night's track under a severe air mass. The hybrid solver tries with A2 equals 0, residuals swell, tries with a small A2, residuals shrink. The system shows both and writes, delta residuals, 23%, direction roughly sunward, likely outgassing. The operator clicks, compare to last clear night only. Improvement persists. The choice is not mystery thrust versus no story. It's sublimation plus geometry, printed without romance. 1935 event orchestration. The planner recomputes value of information. Another 10 minutes on imaging will sharpen afro trends. Spectroscopy still looks bad. The meteor array window opens in an hour. The model suggests a one-off golden frame pass on a terrible field to benchmark calibration, then back to R2. The team agrees maintenance as science, not optional housekeeping. 2040 public divided by ops product. The summarizer constrained by policy prints a small box. Asterisk, delta, uncertainty, cone, /12%, afro modest. A 2-term improves residuals, sunward. Asterisk, uncertainty. Coverage 90% within expected band. Calibration strip updated. Asterisk, next window. Meteor arrays on watch 21/30/22/15. Imaging after dusk tomorrow. Spectroscopy. TBD. No adjectives. A plot, or it didn't happen. 22 false alarm drill. A brightening spike appears. The model screams outburst, then immediately lowers confidence after the QC layer spots thin cirrus. The abstain channel fires. Hold call, re-image. An older pipeline might have tweeted breathlessly. This one waits 12 minutes and posts the boring truth. No outburst. Geometry plus clouds. Hype averted, trust banked. Post-midnight human reflection. The team tags 3 frames where the model hesitated and writes a 2-sentence note on each. Active learning ingests the notes. Tomorrow night, the system will be marginally better, not because it saw the future, but because it listened to its people. This is the kind of hope that lasts. Not magic. Maturity. A loop that shrinks error, honors abstention, and makes every night a little less surprising. Now, scale that story to Rubin. Every few nights, you don't just repeat the loop, you scale it. Cost caps prevent a single night's curiosity from eating a month's budget. Shift alarms raise a yellow flag when twilight statistics drift, forcing the model to slow down and call humans. A community model card lists domain performance. Great here, mediocre there. Abstain recommended in these corners. Public dashboards show uncertainty. Sparklines like weather apps show rain. Citizen scientists can subscribe to regions of the sky as easily as they subscribe to teams or stocks. Science gets faster and more legible at the same time. The ethics return on cue. Asterisk access. If only a few institutions can afford the computing to run the best models, we recreate old inequities with new gloss. Mitigation. Distilled models that run on modest hardware. Federated learning, so small observatories contribute without surrendering data. Asterisk attribution. Auto-summarizers must carry credit metadata. If an amateur's dawn image rescued a link, their handle should appear by default. Asterisk guardrails. A public red channel for expert corrections resets narratives before they ossify. Rate limits blunt, malicious scraping of sensitive targets. Asterisk. Energy. Models cost watts. Publish compute budgets. Reward efficiency. Stop calling waste. Innovation. Came head and, through all of this, keep the comparison honest. 3I divided by Atlas is a worthy long-arc sandbox for the imagination and for model stress tests on exotic orbits. R2 is the weekly exam in adult operations. AI earns its seat when it helps us do both without confusing the timescales or the stakes. Before we close, give the audience a one-page field kit they can remember. Asterisk. For scientists, treat your model's probabilities like a lab instrument. Calibrate weekly. Post the reliability curve. Version your thresholds. Asterisk. For operators, demand an abstain channel and a plain English explain my plan card. If a system can't say why it wants a telescope minute, it doesn't get one. Asterisk. For editors, publish delta. An uncertainty sparkline and the next window. No delta, no story. Asterisk. For citizens, reward plots over adjectives, intervals over points, and abstention over swagger. We started with a picture. Rubin's first perfect night. End with a quieter one. Tonight. If R2 is dull, that is not a failure. It is a well-earned baseline. The pipeline that handled the dull night without drama will handle the loud one without panic. That is the entire wager of AI in astronomy. Not that a model will know what comes next, but that it will help us be the kind of culture that handles whatever comes with clarity. Technology can accelerate mistakes. It can also accelerate corrections. On the 14th of October 2025, choose the latter. Build systems that prefer receipts to rhetoric, intervals to exclamation marks, and maintenance to mythology. Let AI read the sky so people can read the week. And when Rubin paints the southern dome every few nights, let the models sing harmony, not lead, so that science stays human in the way that matters. Honest about uncertainty, generous with credit, and brave enough to be boring when boring is what keeps the world safe. You can watch a telescope age in the shape of its stars. First, the point spread function swells by a sliver so small you shrug. Then the wings thicken, the core softens, and your just this once flat field from last spring migrates into autumn, because the night is busy and the comet won't wait. By the time you notice, the map is bending, centroids slide, residuals bloat, thresholds harden to keep your false positives sane, and the object you meant to protect, this week, it's R2, is now filtered through a stack that's telling slightly prettier stories than the photons deserve. That is instrument degradation in real time, and it never arrives alone. It brings institutional entropy, the quiet loss of memory when teams rotate, patches go undocumented, and law retires with the person who carried it. Let's name the layers so the fix can be surgical. The degradation to decision map runs from optics detector, pipeline people, policy. Asterisk, optics drift, flexure, focus, creep, mirror coatings, aging, baffling that used to tame low-angle light, but now lets in a thin fog at twilight. The symptom is PSF inflation and asymmetry that refuse to be modeled with yesterday's kernel. Asterisk, detectors drift. Nonlinearity grows, hot pixels multiply, read noise shifts with temperature control that isn't as tight as the spec sheet dreamed. The symptom is photometry that just barely disagrees with itself, and astrometry that acquires a tail. Asterisk, pipelines drift. Thresholds set for last year's sky. Cosmic ray cleaners tuned for midnight, but not for civil dusk. Background models that assume satellite streaks are a nuisance, not a norm. The symptom is late candidates or overconfident classifications. Asterisk, people drift. Institutional knowledge turns to folklore. Onboarding squeezes why into what. Night assistants inherit a ritual without the reason it was born. The symptom is a brittle response when geometry gets weird. Asterisk, policy drifts. Maintenance gets traded for time on sky. Change control sounds bureaucratic until the wrong threshold survives 2 epochs. Post-mortems file as victories because nothing exploded. This isn't a condemnation. It's biology with bolts. Entropy does what entropy does. The cure isn't romance. It's refurbish, recalibrate, retrain, anchored by record review, rotate, redistribute. The goal is blunt. Buy time enough clean months to carry the program to its next overhaul. Enough clean nights to make a quiet pass like R2 a lesson, not a liability. Start at the top of the map. Optics. Establish PSF vitals. A tiny dashboard with core FWHM, wing shape, Moffat beta, ellipticity, and a stray light index derived from bright star halos near the field edge. Track them nightly and plot them weekly. If the wing metric crosses a drift threshold, the answer is not an email thread. It's a baffle inspection, a focus rack exercise, and a stray light refit using your stray light cookbook. A living document of low-angle troublemakers, domes, rails, windscreen positions with photographs, not poetry. Detector. Run monthly nonlinearity tests with a stable lamp. Publish the curve as a lab value on the same page as your night logs. Keep a hot pixel farm, a map that updates automatically and seeds your bad pixel mask with a grace period, flag, fast, unflag slow. Tie the CCD temperature control to a drift alarm. If a half-degree count sticks for an hour, the QC panel yells. This is not micromanagement. It's the difference between we saw an outburst and our gain changed. Pipeline. Maintain a threshold ledger. Every detection or cleaning threshold has a number, a reason, a date, and a posture. Green divided by amber divided by red. When a comet like R2 puts you in amber, you lower a specific threshold under a change ID, not a vibe. Alongside, keep a Golden Frames battery, a curated folder of the worst fields you've ever seen. Low altitude, gradients, satellite streaks that look like a music staff. Run them weekly to make sure your normal still recognizes the world. If the battery starts passing too easily, the test has grown complacent. Add a nastier field. People. Build a mentorship matrix. Pair veterans, keepers of law, with new operators, keepers of tools, and reverse mentor. The junior explains how the pipeline actually behaves under Dockerized reality. The veteran explains why the flat sequence was written that peculiar way in 2018. Run 30-minute AARs, after-action reviews, whenever something weird happens. Rule: no blame, only what happened, what changed, what we'll try. Record in a runbook with screenshots. A paragraph written today saves an hour during a near miss like 2025 TF did earlier this year. Policy: institute a lightweight CCB change control board with a simple rule. You can change anything, you just have to say so. A form with 4 fields: what, why, how long. Rollback trigger turns stealth tweaks into memory. Tie that to instrument care. SLO's service level objectives that are about science, not uptime. Median PSF FWHM is less than or equal to X naught. Astrometric residuals 68% is less than or equal to Y. Calibration currency is less than or equal to 30 days. Drift alarms acknowledged is less than or equal to 15 minutes. Add an error budget. You get a monthly allowance for missed targets. Spend it when R2 puts you in amber. Pay it back in green. Why this tone dry, procedural, relentless, under a sky that should be sublime? Because the sublime is a dividend, not a plan. On a week like the 14th of October 2025, the dividend is feeling bored in the best way, while your instruments and your institution do exactly what they said on the tin. The plan is for this segment: let's stitch those controls into a night in the life that doesn't decompose under pressure. Assume dusk windows are short, phase angle is hostile, and R2 is the week's reason to care. Pre-dusk, T, 2 hours. The PSF Vitals panel reports a slow uptick in wing strength over 3 nights. The stray light index crept above threshold last night. The CCB already has a baffle clean plus alignment check scheduled for the next cloudy evening, but tonight, we fly. The threshold ledger toggles to amber posture. Detection. SNR lowered by 0.6, Cosmic Ray Cleaner allowed a softer kernel under a change ID expiring at civil midnight. The Time Server Treaty, a written pact across all observatory computers, confirms NTP offsets is less than 2. Miss A. One-line shell check prints green. Boredom is victory. Civil dusk. T. 0. Seeing is mediocre. Air mass, harsh. The ingestion layer's denoising filters are tuned for the PSF on record, not the one arriving. But your Golden Frames battery tells you how the pipeline lies under exactly this geometry. You press the reprocess with field variant kernels button, because the golden case taught you that the default will eat a faint wedge. The model runs, the QC flags, instrument drift, compensated. You take the first usable frame of R2 with non-sidereal tracking, stars turn to threads, nuclear still as a held breath. T plus 30 minutes, a brightness twitch. Photometry leans high. The drift alarm barks. The detector temperature stepped by 0.3 degrees Celsius. QC suggests a calibration refresh and a double take on the outburst call. You stall on the press note. You run 2 more short exposures. You ask the scheduler for a golden frame to punish the pipeline while the sky steadies. The outburst vanishes as the temperature returns. The log whispers what adrenaline tried to shout. Our gain hiccuped. T plus 60 minutes. Astrometry is noisy. The orbit fit wants a tiny A2 to shrink residuals. The UI prints before divided by after, with confession. Assuming sunward sublimation, compare only to last clear night? You click yes. The improvement holds. The threshold ledger records that your amber posture was used. The error budget ticks down by a notch. You accept the cost because tonight's geometry would have buried the candidate in green. Later, when you look good on the plot, it will be because you were dull on the ledger. T plus 90 minutes. You trigger mentorship matrix mode. A junior operator narrates the steps while a veteran shadow corrects only when needed. The goal is not speed, it's transfer. The AAR template pre-populates fields. R2 Amber Twilight PSF Wing, Temp Blip, a 2 Delta. At the end of the night, a 10-sentence summary gets pushed to the runbook and to a searchable knowledge garden, not an email thread doomed to rot. Post-dusk, T, plus 3 hours. You publish 2 things. A tiny Delta box. What changed since yesterday? Cone shrank, afro modest uptick. A 2-entry improved residuals, and a maintenance note. PSF wings trending. Baffle check queued. Temperature controller hiccup resolved. Thresholds revert to green at 0 local. You consider adding a flourish. You don't. The audience sees the science and the care. The rumor mill gets nothing to eat. That's a good night. But degradation is not a single night problem. It's a curve. So you run a quarterly health review that treats the instrument like a patient. Plot PSF vitals over 90 days. Summarize calibration currency percentiles. List threshold ledger changes with cause. Tabulate AAR themes, stray light, time sync, seeing. Decide whether the refurbishment time has arrived. Refurbish is not defeat, it's prevention. Change out a bearing before it grinds. Replace a coating before it ghosts. Reclock the flat field sequence before a new hire inherits a superstition. Institutional entropy needs its own quarterly. Map, who knows what. Use a skills matrix. Optics, detectors, pipeline code, operations, communications. If red boxes, single-threaded expertise persist, fix them by rotating temporary swaps, retraining structured shadowing, and redistributing. Write the procedure to record the video, post the screenshots. Tie a tiny stipend or time credit to people who document well. Heroics won't save you at 2 under clouds. A paragraph will. What about AI, the shiny tool that promises to smooth out all the rough? Respect it, then domesticate it. Your models must carry calibration curves, expose abstain channels, and obey cost caps. They must announce domain shift, twilight, high air mass, and slow down, not hallucinate confidence. If you don't set these rules, degradation plus automation becomes accelerated wrongness, a quick way to hide real problems under elegant plots. Set the rules, and AI becomes a maintenance ally. It watches PSF vitals for slow tumors, pre-warns when a hot pixel farm is about to overrun, and suggests which golden frame will hurt your pipeline in the most instructive way tonight. The theme remains anxiety with a plan. We worry with a plan. The plan is boring. Boring is what gets you to the morning with dignity intact. The hardest part isn't writing a checklist. It's keeping it alive when the sky is loud, budgets are thin, and people are tired. That's why we translate repair into ritual and memory into infrastructure. Start with refurbish, recalibrate, retrain, document as a rhythm, not a rescue. Asterisk, refurbish on a clock, not a scandal. Announce it like weather. Mirror wash in November, baffling upgrade in December. Expect PSF step change before divided by, after plots will be public. Invite the community to help measure the improvement. Make virtue out of maintenance. Asterisk, recalibrate as first-class science. Schedule a weekly calibration hour that no one can cannibalize. Treat flats and non-linearity tests as a mission, not a chore. Post the curves, brag about a boring plot. Asterisk, retrain before people rotate. Build tabletop drills, a fake temperature blip, a simulated time server skew, a conjured satellite streak massacre. Run them on a cloudy night, and let juniors drive while seniors narrate. Treat competence like a muscle worked, fed, and rested. Asterisk, document in the open. Use a literate runbook, code snippets, plus prose, plus screenshots. The unit of memory isn't a PDF. It's a page that loads fast and is searchable at 2. Next, anchor it with instrument care SLOs. Write 3 numbers you're willing to defend. 1. Astrometry. 68% of residuals is less than or equal to Y arcsec under median seeing. 2. PSF health. Nightly wing index is less than or equal to beta, 0 plus delta for 90% of visits. Drift alarms acknowledged in is less than or equal to 15 minutes. 3. Calibration. Freshness. Median flat field age is less than or equal to 30 days. Nonlinearity curve age is less than or equal to 45 days. These are not commandments, they are contracts. Tie them to an error budget. If R2 pushes you into amber for a week, you spend more of the budget. If 3I divided by Atlas asks for stress testing in off hours, you negotiate a temporary variance. Report budget spend like the weather. People will respect the math if the math respects them. Institutional entropy erodes contracts, unless the contracts are owned. So create roles with teeth but low ceremony. A steward of flats who signs the weekly calibration hour complete. A keeper of time who watches NTP like a hawk. A PSF warden who signs off on the vitals plot. Rotate the roles, they're chores, not crowns. Give quiet credit. A footer on the Delta box that lists the stewards whose work kept the night tidy. Communication is where many institutions give away the advantage they just bought with care. The public doesn't need romance. It needs receipts. The ops team doesn't need a pep talk. It needs clarity. So standardize what lands outside and inside. Asterisk. Outside. Public. The Delta box. The uncertainty sparkline slope of shrinking variance. The next window. And a one-line maintenance note when care was touched the night. If nothing changed, say so. If something broken was fixed, say that too. Asterisk inside. Ops. The AAR bullets. The threshold ledger delta. The PSF vitals plot. And the CCB log links, not attachments. Let search be your ally. How does this posture play with R2 today and 3I divided by Atlas tomorrow? R2 is the stress test that proves your boring work. If a small A two-term tames residuals and a modest afro rise holds for a few nights, you chalk up a win. The pipeline caught it, the ledger recorded it, and the public saw the delta without hysteria. 3I divided by Atlas is your wind tunnel. You try new classifiers, weird domain tags, exotic linking logic off the main lane, on spare compute, with rate limits and red team review before anything touches operations. Curiosity lives, competence rules. There's a final, human layer to buy time. It's the promise you make to each other that maintenance isn't what you do after science. It is science when time is the adversary. The person who presses the reprocess button because the golden frame taught them humility. The person who writes the 3 lines in the runbook instead of the chat. The person who volunteers to be keeper of time for a month. Those are the hands that turn anxiety into option value. On the 14th of October 2025, the world may remember nothing about R2 a month from now. That would be a success. What should persist is your memory. The tighter PSF after a quiet baffle fix. The faster residuals convergence after you pruned stale flats. The smoother handoff because the junior knew not just what to click, but why. That's how you outrun degradation without lying to yourself about physics. You don't cheat entropy. You budget for it. You pay for maintenance, documentation, and training. And you get paid back in nights that bend toward truth without drama. So keep the hook in mind as you close. You can watch a telescope age in the shape of its stars, but you can also watch an institution stay young in the shape of its habits. Refurbish what metal needs. Recalibrate what light demands. Retrain who will carry the next season. Document so the map survives the traveler. That is how you buy time for R2 this week, for whatever the sky throws next month, and for a culture that dares to be calm when calm is what keeps people safe. We don't need a headline now. We need a countdown that respects the clock. On the 20th of October 2025, R2 will slide past at about 0.26 AU, roughly 39 million kilometers, about 100 times the Earth-Moon distance. By geometry alone, that is safe. The Moid sits near 0.048 AU to 7 million kilometers, still safe. And yet, if you've watched the last week with adult eyes, you know why our posture isn't indifferent. Debris risk isn't zero if a comet sheds. You don't need a direct hit to get a lesson. You need discipline under time. So here's the global wrap for the next 6 days alert. Not alarmed because the sky runs on clocks. Actionable hope because clocks make us competent when we keep our promises. No doom, no swagger. Just a plan. First, the picture we carry forward. R2 has behaved like an active comet under sunlight. Green coma from C2, water proxy OH in narrowband instruments when available, a dust continuum that rises and falls with phase angle, and a tail that hints at localized vents. Orbit solutions converge faster when a small A2, the sunward, thermal cycle-linked non-gravitational term, is allowed. That's not a mystery thrust. That's sublimation being itself. Our uncertainty cone has been shrinking as cadence improves. Afro has drifted inside a modest band. Meteor arrays have not reported a sustained, time-locked uptick that would trigger operational posture for satellites. In plain language, Category A, trending B, on our debris model, parent intact, dust ordinary to modest, with the standing caveat that comets can change their minds at bad hours. Second, the operational mindset. We will treat October 20 not as a spectacle but as a checkpoint. The number that matters isn't the nominal miss. It's whether there's evidence of fresh ejection that could later align with Earth's orbital plane, nudging the micrometeoroid background in narrow time windows. That's why our watch list centers on ephemerides, spectroscopy, imaging for fragmentation, radar, if marginally possible, and meteor flux, versus a well-understood baseline. If none of those moves meaningfully, the right headline on October 21 is, "Nothing happened." Here's what that taught us. Third, the comparison the internet is itching for. Apophis, the 13th of April 2029. Keep the scales honest. Apophis will pass at roughly 31,000 kilometers below geostationary altitude. That's inside our satellite architecture, a choreography we've rehearsed for years. It's a predictable, close approach, with an orbit solution we trust and an entire international community writing drills around it. R2 is not that. R2 is a safe flyby with a comet's personality, outgassing, dust, the occasional twitch that shrinks residuals when you let physics speak. We juxtapose them to learn from the contrast: predictable proximity, apophis, versus distant stochastic nuisance potential, R2. Both require competence. They require different kinds. With that mood set, we'll move from summary to roadmap: what gets watched, who acts, what triggers action, and how we'll talk about it. Layer 1. Science measure, don't guess. Asterisk ephemerides and uncertainty decay. Post-nightly solution deltas. Semi-major axis of the cone, 68 divided by 95% bands, and whether non-grav terms remain justified. KPI is greater than or equal to 10% shrink in cone semi-major axis over 48 hours or stable plateau. If expansion